Hey guys, I welcome you all to the live session on Natural Language Processing by Intellipaat. This session is conducted by multiple experts who will be teaching you all about natural language processing from basics to advanced level, along with hands-on demo and interview preparation. But before we begin the session, make sure to hit the subscribe button and also hit on the bell icon so that you will never miss an update from us. On saying that, let's see the agenda of the day. Firstly, we will begin with Introduction to NLP. In that, we will be explaining you what is NLP, what is the use of NLP, and what are the components of NLP. Then later on, we will learn about tokenization and packages for NLP. Then once we finish with that, we will learn about unigram, bigram, and trigram in NLP. Post that, we will learn few interesting topics like stemming, lemmatization, parts of speech tagging. Then later on, we will introduce you to Spacy and Natural Language Toolkits. Then after that, we will learn about sentimental analysis using Natural Language Toolkit. Post that, we will be learning about the most interesting topic of NLP, that is text mining, and also NLP Toolkit in Python. Then after that, we will be doing an AI project on HR analytics. Then lastly, we will be covering NLP interview questions and answers. So, this is the agenda of the video. Without any further delay, let's get started.
So let me start off by asking a very simple question. What do you understand by the term natural language? Well, simply put, natural language is any language which has evolved naturally in humans. So any of these languages, English, Hindi, French, Telugu, or any of the numerous languages which has evolved naturally in humans through use and repetition without conscious planning can be termed as natural language. Now, since we're humans, we're able to comprehend these languages. But what about a machine? What if these same languages are fed to a machine? Will it be able to comprehend them? So this is where natural language processing comes in. So natural language processing is the ability of a computer program to understand and interpret human language as it is spoken. Or in other words, NLP is used to gain knowledge from the raw textual data at our disposal. Now let's go ahead and look at the components of NLP. So NLP can be basically divided into natural language understanding and natural language generation. So let's start with natural language understanding. So NLU, as the name states, deals with understanding the input given in the form of sentences in text or speech format. And this is where the machine analyzes the different aspects of language. Then we have natural language generation. So NLG deals with turning raw data into simple human understandable language, or in other words, producing natural language from raw input. Now to implement the NLP concepts, you would need some packages tailor-made for natural language processing. So in today's session, we will work with two such packages which are NLTK and Spacy. So generally the first step in NLP process is tokenization. So in tokenization, we basically split up our text into individual units, and each individual unit should have a value associated with it. So let's take this example. We have a sentence, Joey doesn't share pizza, and we are splitting this up into individual tokens where each word is taken as a separate token, and also the exclamation marks are taken as separate tokens. Now, we can use these tokens for another process like parsing or text mining. So let's actually head on to a Jupyter notebook and learn how to tokenize a sentence using the NLTK package. So we'll start off by importing NLTK and NLTK.corpus. I'll run this. After that, we would require the word_tokenize function from the NLTK.tokenize package. So we'll also import this function from NLTK.tokenize. I'll click on run. So over here we have a string. So after surprising the host in the first test, Sri Lanka made a positive start to the second test. So this is the entire string over here, and I am storing it in an object named as cricket. Now what I'll do is, I will pass in this object inside the word tokenize function, and I will store the result in cricket_tokens, and I will print this out. So this is the part where we are basically tokenizing this entire string into individual tokens with the help of this word underscore tokenize functions. So I'll click on run. Right. So we see that this entire string is split up into individual tokens. After is one token, surprising is token, the is token, whose is token. So again, we've taken up this entire string and split this up into individual tokens. Now, after doing that, let's also have a glance at the type of this and the number of tokens we have. I'll click on run. So you see that this is a list of all the tokens and we have 201 tokens in total. Now let's also get the frequency of these tokens. That is, I want to find out the number of times each token value occurs. And for that, I would require the frequency dist from NLTK.probability package. So I'll import this and I will create an instance of this with the name fdist. Again, I'll click on run. Now I will create a for loop where this I value will iterate through all of the tokens, and for each token I will keep on adding the count wherever it is encountered, and finally I will print this out, which is fdist. So I get the frequency of all the tokens over here. So you see that the occurs 11 times, comma occurs 8 times, A occurs 6 times, for occurs 6 times, South and Africa occur 5 times, right? So this basically is the frequency distribution of all the tokens. Now if I want to find out the 10 most common tokens, then I have this most common function. So I'll call fdist.mostcommon and I'll pass in the parameter which is 10. So this will give me the 10 most common tokens and I'll store it in top 10 and I'll print it out. I click on run. So these are the 10 most common tokens. So the is the most occurring token which occurs 11 times. Now human beings can understand linguistic structures and their meanings easily, but machines are not successful enough on natural language comprehension yet. So when a machine has to pass through one word at a time, it may not be able to fully understand semantics of a sentence. And these words, when given one at a time, are known as unigrams. So let's take this language over here. I love natural language. And when each of these tokens are given one at a time to the machine, this is nothing but a unigram. I love natural language. So these are basically unigrams given to the machine. And similarly, when the machine is given two words at a time, it is known as a bigram. So this is a bigram. I love natural language. So this entire sentence is basically being given in the form of two tokens at a time. And similarly, when this entire sentence is given three words at a time, it is known as a trigram. So this time it is split like this. I love natural is one part and then we have love natural language, right? So this is the trigram which we have over here. So again, let's head back to Jupyter Studio and learn how to create bigrams and trigrams. So over here we have this sentence. Did you know there was a tower where they look out to the land to see people quickly passing by? And I've stored this in black smoke. So I'll just quickly hit on run. Now I will tokenize this sentence with the help of the word tokenize function, and I will store this result in black smoke token and then I'll print it out. I'll click run. So these are the individual tokens from this entire sentence which we have over here. Now if I want to create bigrams and trigrams from this, we have the NLTK.bigrams and NLTK.trigrams function. So I will use this NLTK.bigrams function and then pass in these individual tokens inside this function, right? So I am passing this black smoke token object inside the NLTK.bigrams function and I want to see the result in the form of a list. So I click on run, right? So now these individual tokens are being represented in the form of bigrams. Did you know there was. Similarly, if I want to represent these tokens in the form of trigrams, I will use the NLTK.trigrams function and then pass in this object which is black smoke token. Again, I'll hit on run. Now we have trigrams. Did you know there was, right? And finally, we have something known as n-grams. So ngrams basically has an additional parameter over here. So if I want 4 words together, I'll put in 4. If I want 5 words together, I'll put in 5. Similarly, if I want 10 words together, I'll just put in 10 over here. So for that, I'll have to use the NLTK.ngrams function, and the first parameter inside that would be the list of tokens. After that, the parameter which would tell us the number of words together. And this time I want to see 4 words together. I'll put in 4 and then I'll click on run. Right, so over here we have 4 words together. So now let's understand stemming. So stemming is the process of reducing a word to its base form. And this is done by cutting off the beginning or ending of the word. So this indiscriminate cutting will be successful in some occasions and fail in other. So let's take these 3 examples over here. So this first case, studies, we have cut off the suffix es and it becomes study. And the second case, giving, we have cut off ing and it becomes giv. And in the third case, we have cut off ing from buying and it becomes buy. So in all the 3 cases, we see that only in the third case, we have a word which makes sense. So when we are implementing stemming, it is always not necessary that the final stemmed word which we get should have a meaning associated with it. Now there are many stemming algorithms available. So one such stemming algorithm is Porter stemmer, and we'll be importing this Porter stemmer from NLTK.stem package. After that, I will create an instance of this Porter stemmer with the name PST. I want to stem these 3 words over here: winning, studies and buying. So I will pass in these 3 words inside pst.stem. So pst is the Porter stemmer instance, and this instance basically has the stem function. So I want to stem the word winning, the word studies and the word buying. I'll hit on enter. So I just have to run this first. Now I'll click on run again. Alright. So we see that winning has been stemmed to win, studies has been stemmed to study, and buying has been stemmed to buy. Now, similar to stemming, we also have lemmatization. So lemmatization is the process of reducing words into their lemma or dictionary. So the base form into which the word is converted should definitely have a meaning associated with it. So again, we have 3 cases over here. Studies is converted to study, which obviously has a meaning. Giving has been converted to give. Similarly, buying has been converted to buy. So see that these 3 individual base words have meaning associated with them. Now to implement lemmatization with the help of NLTK package, we would need the WordNet and WordNet Lemmatizer. So we will be implementing these 2 from NLTK.stem packages. And I will create an instance of this WordNet Lemmatizer. Now what I want is, I want the lemma forms of these 3 words: cats, cacti and geese, and I will store this in this object words to stem. So after that, I will basically create a for loop which will go through these 3 words and lemmatize each of them. I'll hit on run. Right, so you see that cats has been lemmatized to cat, the lemmatized version of cacti is cactus, and finally the lemmatized version of geese is goose. Now, another important concept of natural language processing is parts of speech tagging. So in the English language, words can be considered as the smallest elements that have distinctive meanings, and based on their use and functions, words are categorized into different classes which are known as parts of speech. So POS tagging is the process of marking or tagging every word in a sentence to its corresponding part of speech. So let's take this sentence: Joey loves pizza. Now we can mark each of this word with a POS tag. So the word Joey is a noun, loves is a verb, and similarly pizza is a noun again. So we'll be adding POS tags to this sentence over here. What do you mean I don't believe in God? I talk to him every day. And I've stored this in this object peace. Now again, first task would be to tokenize this sentence. So I will use the word underscore tokenize function and pass in this object, and I'll store the result in peace tokenize. So let me execute these 2. Now I will start a for loop which will iterate through all of the tokens, and for each of the token I will add a POS tag with the help of this POS tag function. So I will use this NLTK.POS tag and add a POS tag to each of the individual tokens from this piece tokenized list. I'll click on run. Right. So we see that each of these individual tokens has been marked with a POS tag. So what has a POS tag of WH pronoun, do has a POS tag of verb, you has a POS tag of personal pronoun, and mean has a POS tag of noun. Right, and similarly we have these POS tags for the rest of the tokens. Now let's also add POS tags for another sentence over here. So this sentence is, Mary had a little lamb whom she really loved, and we are storing this in the object Mary. Now again I'll use the word underscore tokenize function and pass in this object, and I'll store the result in Mary underscore tokenize. After that I'll use this for loop which will iterate through all of the tokens and add a POS tag to each of the tokens. I'll hit run. Right, so Mary is a proper noun, had is a verb, a is a determiner, and similarly we have other POS tags associated with each of the words. Moving ahead, we'll understand what is named entity recognition. So named entity recognition is the process of taking a string of text as input and identifying relevant nouns such as people, places, and organizations that are mentioned in that string. So in the sentence, Apple buys UK startup for $1 billion. Apple has been recognized as an organization. UK has been recognized as a geopolitical entity. And $1 billion has been recognized as money. Now one thing to be noted over here is all these three words are nouns. So named entity recognition is done only on nouns. And to do named entity recognition, we would require this any underscore chunk function. So we'll import this from the NLTK package. I'll hit on run, and we would want the named entity recognition for this sentence over here. John lives in New York. I'll store this in John. Again, the first task is to tokenize this sentence. So I'll use the word underscore tokenize function and pass in this object John inside this. I'll store it in John underscore token. I'll click on run. Right, so we have tokenized this. After that, we will add a POS tag with respect to each of these tokens. So I'll use the function nltk.pos tag and pass in these tokens, and I will store this in John tags, and I'll print this out. Right, so we have a POS tag associated with each of these tokens. John is a noun, lives is a verb, N is a conjunction. Right, now finally it's time to get the named entity recognition of these POS tags. So I will use the any underscore chunk function and pass in this John underscore tags object inside it, and I'll store it in John underscore ner. After that I'll print it out. Right, so see that John has been recognized as a person. Similarly, New York has been recognized as a geopolitical entity. Again, the thing to be kept in mind is the named entity recognition is done only on nouns. John is a noun, New York is a noun, right? So that is why John has been recognized as a person and New York has been recognized as a geopolitical entity. So all of those tasks were done with NLTK. Now we also have Spacy, which is a relatively new framework in the Python natural language processing environment. But it will quickly gain ground and will most likely become the de facto library for natural language processing. So Spacy is written in Python language, that is C extension of Python, which gives C-like performance to the Python program. So let's go ahead and import the Spacy package. Now the Spacy package has different models. So we'll load the EN Core Web Small Model and store it in NLP object. I'll hit on run. Right, now using this NLP object I can create different documents. So these documents basically contain strings. So each string can be classified as a document. So I will store this is Pata inside this document. I'll click run. Now, so tokenization is very simple when it comes to a Spacy package. So all I have to do is start a for loop and print all of the tokens present in that document. So for token in doc, so it will iterate through all of the tokens present in the doc and print the text of all of the tokens. I'll hit run. Right, so these are the 5 tokens which are present in the string. This is Sparta, and then we have 2 exclamation marks. Now after that, let's see if I want to get the third token from this. So if I want to get the third token, then that is present at index number 2 of this document. So 0, 1, 2. So that is why I'll pass in doc and I will give in the index number which is 2 and I'll store this in token, right? So the third token is Sparta. Similarly, if I want all the tokens present at second, third and fourth indexes, so I can use this. So inside the parenthesis of doc, I will start at 2 and I'll end at 5. So this will basically give me all the tokens starting at second index and ending at the fourth index. Now let me go ahead and print the token index and the token text together. So this is a document, this is Sparta. Now in this print command, I am first printing the token index which I get with the help of token.I. After that, I am also printing the tokens text which I get with the help of token.text, right? So I have the token index and I have the corresponding token text to each of these index values. Now similarly, let me also do POS tagging with the Spacy package. So for that, the document is Joey doesn't share pizza, and I will iterate through all of the tokens in this document. First, I will print in the index of the token. After that, I will print in the text of the token, and finally I will print the POS tag of these tokens, right? So we have the index value, we have the token text, and we also have the POS tag corresponding to each of these tokens. Now similarly, we can also do named entity recognition. So for this, we have the string Apple is looking to buy UK startup for $1 billion. And obviously I've stored it in this doc object. I'll click on run. And over here we have this for loop for ent in doc.ents will print out the entity's text and also the corresponding entity label. So basically doc.ents comprise of all the entities and the corresponding labels with respect to the entities recognized. So I'll hit on run. Alright. So this doc.ents has recognized these three entities. Apple has been recognized as an organization. UK has been recognized as a geopolitical entity and $1 billion has been recognized as money. Barack Obama, the former president of United States, will be vacating White House today. I'll click on run. Again, I'll start the for loop and I will print the entity and the corresponding entity recognition. Right, so Barack Obama is recognized as a person, United States is recognized as GPE, and today has been recognized as date. And finally, we have also something known as matcher from Spacy. So this matcher helps us to find patterns in a string with different criteria, such as understanding the lemma of the word, understanding if the word is a digit or not, understanding if the word is a punctuation mark or not, so something like that. So let's do some pattern matching on the string over here. Barack Obama, the former president of United States, will be vacating White House today. Again, I will store this in doc. So now, first I will create a pattern. So pattern is basically created as a list of dictionaries. So each dictionary indicates a word. So the first word we are basically trying to match with the lemma value. So the first word's lemma should be vacate. And after that it needs to be followed by another word which is white, right? So I want to extract a substring from this entire doc which is basically two words. The first word is a lemma variation of vacate and the second word is white. Now I will create an instance of matcher by passing in nlp.vocab inside this. Now this matcher instance has this add function which basically takes in three parameters. First parameter is the ID, which helps us to uniquely identify this pattern matching. After that, the second parameter is basically the callback function, which I have stated as none over here. And the third parameter is the pattern which I want to identify from the string. So I've given these three parameters. After that, I will pass in the document inside the matcher function and I will store it in matches. I'll hit run. Now, this matches object will basically comprise of three things: match ID, start index and the end index. And I will put these three inside the for loop and get the substring from this document. So I'll hit on run. Right. So I have successfully extracted vacating white from this entire string over here. So the pattern basically was the first word needs to be a lemma variation of vacate and it needs to be followed up with the word white. Now similarly, let's also do pattern matching on this string over here. 2018 FIFA World Cup, France won. I'll click run. So this time the pattern matching should be something like this. The first word should be a digit, second word should be FIFA, third word should be world, and the fourth word should be cup. Again, I will create an instance of this matcher and I'll pass NLP.vocab inside this. After that, I will use the add function and give these three parameters. So ID is FIFA pattern, second parameter is none, and the third parameter is basically the pattern which I want to extract from the string. And after that, I will use this match2 and pass in this document inside this and store the result in matches2. I'll click run. So again, I'll use this for loop and extract the substring from this original string. I'll click on run and I have successfully extracted the substring, which is 2018 FIFA World Cup, from this original string over here. Right, so this is how we can implement NLP concepts with the help of NLTK package and Spacy package.
So now we'll see how to do sentiment analysis using the NLTK package. So we'll start off by loading all of the required packages. I'll import NLTK, I'll import random, and we'll also be doing a bit of classification. So for that purpose, we would require all of these classifiers. So we'll need sklearn classifier, we'll be implementing the naive-based classifier, SGD classifier, logistic regression, and SVC. So I'll be importing all of these. So I'm importing multinomial NB, Bernoulli NB from sklearn.naive-base, and I'll also import logistic regression and SGD classifier from sklearn.linear model. And also we'll be implementing the support vector classifier. So I'll be importing SVC, linear SVC, and NUSVC from sklearn.svm. Right. And we would also have to do a bit of pre-processing of the data which we have. So for that purpose, we would import the word tokenize from nltk.tokenize. And to load the file, we would require the OS package. So I'll also import that. I'll click on run. So we have imported all of the packages that we need. Right, now it's time to load our data set. So we'll be performing sentiment analysis on top of the IMDb reviews data set. So this basically consists of 25,000 reviews, and out of these 25,000 reviews, 12,500 are positive reviews and the rest 12,500 reviews are negative reviews. So these two are stored in separate folder. So there is one folder called as POS and it would contain all of the positive reviews, and there is another folder called as NEG and it would contain all of the negative reviews. Right. So first I will load all of the positive reviews into files underscore POS. So these are the two lines over here. So what I'm doing is I am reading every single review as a single line. So for F in files underscore POS, what I'm doing is, so for every positive review, I'll read it and I'll store it into files underscore POS, right? So files underscore POS would have all of the positive reviews. And similarly, I'll do the same thing. So all of my negative reviews are stored in this NEG folder. So this is the entire path is of D drive, and the folder which has the negative reviews is NEG, and I will keep reading every single review and I'll store it in files underscore NEG. I'll click on run. So this is a huge dataset which comprises of a lot of files. So now I have my positive reviews and my negative reviews. Let me find out the length of both of these. So as I told you guys, there are 12,500 positive reviews which are stored in files underscore POS, and similarly there are 12,500 negative reviews which are stored in files underscore NEG. Right. So now we have our positive reviews and negative reviews with us. Now, if we want to implement all of the classifier algorithms and if you want to do processing on top of all of these files, then it would consume a lot of time, right? So what I'll do is I'll just take a subset of this. So from the 12,500 positive reviews, I'll just select the first 1,000 positive reviews, and similarly from the 12,500 negative reviews, I'll just select the first 1,000 negative reviews and I'll store them into the same data sets. So now files underscore POS has the first 1,000 positive reviews and files underscore NEG has the first 1,000 negative reviews. I'll click on run. Right. So this is done. Just to verify, let me again have a glance at the length of files POS and files NEG. So we see that there are 1,000 and 1,000. Right. So there are 1,000 positive reviews and 1,000 negative reviews. Now it's time to pre-process all of these reviews. Right. So I'll start off by creating two empty lists over here. So first empty list is all words and second empty list is documents, and I'll import stop words from NLTK.corpus. So my first task in pre-processing would be to remove all of the stop words.
Just a quick info, guys. Test your knowledge of NLP by answering this question. To which of the following fields does NLP belongs to? A. Computer science. B. Artificial intelligence. C. Linguistics. D. All of the mentioned above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So I'll just set over here list set stopwords dot words, and I will get the list of all of the stop words in English, and I will store all of those stop words in this object stop_words. Right. Now this is done, and what I actually want now is bag of words or bag of adjectives, because adjectives are a better way to understand the sentiment of a review, right? So let's say there are some adjectives such as great, good, or bad, right? These are all of the words, or adjectives are the main words which tell us about the sentiment of a review. And that is why I would want only the adjectives from the entire review. So now during POS tagging, each of these parts of speech have a different letter assigned to them, such as adjective is denoted with J, adverb is denoted with R, and verb is denoted with V. So since I want only the adjectives, I will set over here that the allowed word types are only J, or in other words, I want only the adverbs from all of the parts of speech. Right. So this is the initial pre-processing. Now I'll start this for loop, and it goes through all of the reviews in files_POS. So for P in files_POS, it starts with first review and goes on in the 1000 positive reviews. So now I have this empty documents list over here, and using this, what I'll do is I'll actually create a list of tuples where the first element of each tuple is a review and the second element is the label of the review, right? So P, it is basically for P in files_POS. So over here, if we start in the for loop, then it will have the first review, and over here POS basically means that this review is positive. Again, this will iterate, and then we will have the second review, and again the second review is also positive. Then we'll have the third review, and again we'll set the label which is positive again, right? So this will go on inside this loop. Now once we create this list of tuples, we also have to remove the punctuations present in the reviews. So I'll pass in P over here, and this is the syntax to remove all of the punctuations, right? And this is how I'll remove all of the punctuations. So now I've removed the punctuations. Now it's time to also tokenize my words. So tokenizing words is very important. So each individual word or each individual element present in all of these reviews would be tokenized. And for that purpose, I would have to use the word_tokenize function, and I will pass in this cleaned object into this. So this cleaned object is that object which does not have any punctuations. I'll pass it inside the word_tokenize. Now, once it is tokenized, I will store the result in tokenized. Right. So now we have the tokenized result, and we would have to remove all of the stop words from all of these tokens. So let's understand this over here. So W for W in tokenized, if not W in stop words. So this basically means that if the token is not present in stop words, then go ahead and store it into stopped. And this loop will continue, and we'll get only those tokens which are not present in stop words, right? So we have successfully removed all of the stop words, and I will pass this object inside NLTK.pause tag function. With the help of this, I can do the POS tagging of all of the tokens, right? So I have all of my tokens with me, and I'll just do the POS tagging or the parts of speech tagging for all of the individual tokens, and I'll store it into POS. And this is where I have all of the tokens associated with a parts of speech tag. Now, as I already told you earlier, from all of these parts of speech, I would want only adjectives. I do not want all of the parts of speech. So over here inside this loop, what I'll do is I will just select only those tokens which are present in allowed word types, or in other words, I am extracting only those tokens which are adjectives, and I will store all of them in all words. right? So now all words has all of the positive adjectives present in it, right? So we have stored all of the positive adjectives into all words, and we'd have to do the same thing for all of the negative reviews. So this time I'll start the loop for all of the negative reviews. So this will go like this: for p in files underscore neg. And over here, I am again creating a list of tuples where the first element of each tuple is the review, but this time this is the negative review, right? So this is the negative review which is present in files underscore neg, and I will also associate a label with it, which is neg this time, right? Since over here this is a negative review, I have the review over here, and the label is neg, which tells us that this is a negative review. Now this is done. I would also have to remove all of the punctuations present inside this negative review. So I'll just type in re.sub, and this is how I can remove the negative punctuations. And then I'll go ahead and tokenize the words. So I'll pass in this cleaned object into word tokenize, and we'll store all of the tokens in tokenized. Now it's time to remove the stop words. So W for W in tokenized, if not W in stop words. This means that this loop will go through all of the stop words, and if the token is not present in stop words, only then that token would be stored in the stopped object. Or in other words, I would want only those tokens which are not present in the stop words object. So I have removed the stop words. Now it's time for parts of speech stacking. So I'll pass this stopped object into NLTK.pos tag, and this helps me to do parts of speech tagging to all of the tokens. Now for sentiment analysis, I would require only the adjectives and not all the parts of speech. So again, I'll start this for loop, and this for loop will go through all of the tokens present in neg, and it will extract only the negative adjectives and it will append to all words. So initially in the above for loop we had all of the positive adjectives, and with the help of the below for loop we have all of the negative adjectives appended to all words. So now this all words is a combination of all of the positive adjectives and all of the negative adjectives, right? So now we have our bag of words or bag of adjectives with us. So now I'll go ahead and create a frequency distribution for all of these adjectives. And for that purpose, I'd have to use nltk.frequency, and I'll pass in the all words object inside this. I'll click on run, and this is the frequency distribution. So see that the adjective good occurs 1157 times, bad occurs 743 times, great occurs 660 times, much occurs 482 times, and so on. Now, let me also visualize this graphically. So I'll import matplotlib, and I'll just make a simple line plot for this. So this is our line plot, and we see that good is the adjective which occurs most number of times over here, and it occurs around 1157 times. Now out of all of these adjectives, I would want the 1000 most frequently occurring adjectives, right? So I'll just extract the 1000 most frequently occurring adjectives. So I'll type in all words.keys, and I'll extract the 1000 or the first 1000 adjectives, and I'll store it into word features, right? So these are the 1000 most frequently occurring adjectives over here. So now we'd actually have to create a tuple where the first element is a dictionary and the second element is the label positive or negative. So to create the dictionary of features, we'll actually use this user-defined function. So what we'll do is we are supposed to create a dictionary of features for each review present in the list document, right? So for each review present, we will create a dictionary of features. Now in this dictionary, the keys are all of the words in word features, and the values of each key are either true or false, which basically tell us whether that feature appears in the review or not. And it basically looks something like this. So we have a tuple. The first element of the tuple is a dictionary, and in that dictionary the key basically comprises of all of the adjectives, and the value is basically true or false, which tells us if the adjective is present in the review or not. And then the second element of the tuple is basically POS or NEG, which would tell us whether the review is positive or negative. And we are doing this because we'd want to find out whether this particular review is positive or negative. So this user defined function which you see, this helps us to do something like that. Now out of that we will create this feature set. So this feature set is nothing but our tuple, where the first element is a dictionary and the second element is basically the label, which is POS or NEG. And then I'll go ahead and shuffle these feature sets, and I will divide these feature sets into training and testing data. So the training data would comprise of 800 reviews and the testing data would comprise of 200 reviews. So the first 800 features go into the training set, the last 200 features go into the testing set. I'll click on run. Now let me have a glance at the first feature set, right? So this is our dictionary over here, which is the first element. So what we see is this. So this is the adjective, and this false basically tells us that this adjective is not present in the review. So let's actually find for true, right? True, and it is BR. So this tells us that BR is present in the review. Let us find for some other true value, right? Better is present in this review. Let me also find some other true label. Let's see, where do we get a true label down? Right, so over here we have mediocre. So mediocre is present in this review. So wherever we have false, it basically means that those adjectives are not present in the review, and wherever we have true, it means that those adjectives are present in the review. Now let me go totally down and let me see what is the label. So this is pause, right? So combining all of the adjectives which are present in the review, when combined, they give us the positive label. And this is the training set. Now what I want is, I would build a couple of classifiers on top of this training set, and once the learning is done, I will try to predict the values on top of the test set and see whether the prediction is correct or wrong. So the training will be done on this training set. It learns all of these features, it learns the labels. Once that is done, I'll predict the values on top of the test set. So I'll start off by implementing the naive base classifier. So I'll just type in NLTK.naive base classifier, and I will train it on top of the training set, and I will check for its accuracy on top of the test set. And I'll just print it out. And after that, I would also want to show the 15 most informative features from this classifier. So I'll click on run. So we see that we get an accuracy of 75.5% when we build this model on top of the training set. And these are the most informative features, right? So powerful, serial, cheap, unique. So these are the 15 most informative features when we build this classifier. And on the right side, what you see over here is the ratio of positive to negative is 11.3 to 1.2 for this adjective. This means that the word powerful is 11.3 times more likely to occur in a positive review than a negative review. And this is for serial, and this is negative to positive. This means that the adjective serial is 8.1 times more likely to occur in a negative review than a positive review. Again, we have cheap. So over here, this word cheap is 6.5 times more likely to occur in a negative review than a positive review. And again, let's take this superb adjective over here. So this means that the word superb is 4.9 times more likely to occur in a positive review than a negative review. So we have implemented the naive base classifier on top of the training set, and we've got an accuracy of 75.5%. Now we'll go ahead and implement some other classifiers. So we'll start with multinomial naive base, then we'll implement binomial naive base, then logistic regression. After that, SGD classifier, which is basically stochastic gradient descent, and finally we'll also implement SVC, which is support vector classifier. So let me import all of these packages first. Right, so we have imported all of these packages. Now we'll implement the first classifier, which is multinomial NB. So I'll just create an instance of this, and I'll store the instance in MNB CLF, and I will train this classifier on top of the train set, and I'll store it in MNB CLS. Now since I've built the model on top of the train set, I can go ahead and predict the values on top of the test set. So again, I'll just type in nltk.classify.accuracy. So I want the accuracy where my predicted results are stored in MNB_CSL, and my actual values are in the test set, which is basically the testing set. Let me print this out. So we have built the multinomial naive base classifier, and we've got an accuracy of 77.5%. Now we'll build the binomial naive base classifier. So I'll just create an instance of binomial naive base and store it in BNB_CLF, and I will fit this model on top of the train set and store the result in BNB_CSL. Now again, since I fit the model on top of the train set, I can go ahead and predict the values on top of the test set. So I'll use NLTK.classify.accuracy, and over here this takes in two parameters. First parameter is basically the object which contains all of the predicted values, which is BNB underscore CLS, and this is my test set which comprises of the actual values. So let me click on run. And this time I get an accuracy of 75% with the Bernoulli naive Bayes. Now I'll implement the logistic regression algorithm. So I'll create an instance of it and I'll name that instance to be logreg underscore CLF, and I'll fit the model on top of the training set again, and I'll store the result in log underscore CLS. Similarly, I'll get the accuracy by predicting the values on top of the test set. So with the logistic regression algorithm, I get an accuracy of 72%. Now we've got two more classifiers left. So this time we're going to implement the SGD classifier, which is the stochastic gradient descent classifier, and I'll name the instance of this to be SGD underscore CLF, and I'll fit the model on top of the train set and store it in SGD underscore CLS, and I will predict the values on top of the test set. I'll click on run. Right. So with the stochastic gradient descent classifier, we get an accuracy of 68%. So you see that the accuracy keeps on decreasing over here, right? So we started with multinomial naive Bayes, which gave us an accuracy of 77.5. Then Bernoulli naive Bayes gave us an accuracy of 75%. Logistic regression gave an accuracy of 72%. SGD gave an accuracy of 68%. Now let's see what accuracy the SVC classifier gives. So I'll click on run. So the support vector classifier gives a very low accuracy, which is just 49.5%. So now if I compare all of these accuracies, then I see that I get the highest accuracy with the multinomial naive Bayes classifier, and the accuracy is 77.5%. So we can basically choose this model over all other models when we are trying to ascertain the sentiment of these words. Right, so this is how we can do sentiment analysis using the NLTK package and the scikit-learn package.
Just a quick info, guys. Intellipaat provides NLP training using Python mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
So, what in the world is text mining? Well, simply put, extracting information from unstructured textual data is known as text mining. Now, let's say there's a 500-page thesis on some financial topic, and you come across a sentence which ends with the number 30. Now, you have absolutely no idea what that number means. It could be the number of days in a month, the amount of dollars a stock increased over the past week, or the number of items sold in a day. So this number 30 could mean anything, and without proper context, you wouldn't get the right information. And this is where text mining comes in. So with the help of text mining, we can give proper context to the words before and after the number 30. And this would help us to find out more information. Now let's look at the need of text mining. So today, with the advent of social media, companies now have access to massive behavioral data of their customers. And most of this data is present in the form of unstructured textual data. But beneath this textual data lies an enriching source of information which can help companies to boost their business. And this is the reason why text mining is being used across various industries. Now, text mining can be divided into 4 practice areas. So we've got information extraction, which basically deals with identification and extraction of relevant facts and relationships from unstructured data. Then we have document classification and clustering, which aims at grouping and categorizing terms, paragraphs, or documents using classification and clustering methods. After that, we have information retrieval, which aims at storage and retrieval of text documents. And then we have NLP, which forms the major part of text mining. So here we use different computational tasks to analyze and understand the underlying structure of the text data. Right, now we'll dive into NLP. So when you hear the term natural language processing, the first question to pop into your head would be, what is a natural language? So any language that is used for communication by humans is known as natural language. So English, French, Chinese, all of these are natural languages. Now, since we are humans, we're able to understand these languages. But what about a machine? How is a machine able to comprehend all these human spoken languages? Well, this is where NLP comes in. So natural language processing is a subdomain of artificial intelligence,
where we understand and interpret human languages using a computer. Now, let's see how is NLP used in text mining. So just think about how much text you see each day. Email, SMS, web pages, the list is just endless. So with the help of NLP, we can go through all of this text data and use it for different purposes such as character recognition, sentiment analysis, and spell checking. Right. Now we'll go ahead and install Anaconda into our systems. So Anaconda is basically a free and open source distribution for Python and R programming languages. And it is specifically designed to perform data science and machine learning applications. Right, so these are the 4 steps to work with Anaconda. So first we'd have to download the Anaconda installer and then we'll install Anaconda. Then we'd have to open Anaconda prompt and update Anaconda. Right, now let me just guide you how we can do this. So first we'd have to go to this website anaconda.com distribution download section, and you'd have to download the version for whichever operating system you're using. So if you're using a Windows system, then you'll download Anaconda for Windows. If you're using Mac, then you'll download it for Mac. And if you're using Linux, then you'll download it for Linux. Now, you've got 2 versions of Python. So Python 3.7 and Python 2.7. And we'll be downloading the latest version of Python, which is Python 3.7. So once we download this, we have this setup wizard over here. So we just have to click on next and it'll take care. Now, once the installation is done, we'd have to open up the command prompt. So this is what we get when we open the Anaconda prompt. Now inside this, we'll have to type in conda update Anaconda, and we'll have the latest version of Anaconda in our system. Alright, now let me just go ahead and show how to do it. So I'll just type in download Anaconda. I'll click on this link over here, Anaconda Python R distribution. And over here, I'll click on this download. So I've got different versions over here for Windows, Mac and Linux. And since I'm using a Windows system, I'll download Anaconda for the Windows system. So this is the latest version of Anaconda, Python 3.7. I just have to click on download. Right, so once the download is done, I'll get a setup wizard and I'd have to set it up. And I'll go and click on Anaconda prompt. So this is my Anaconda prompt over here. So now that we've successfully installed Anaconda into our systems, we'll go ahead and work with the OS module. Right. So the OS module, it provides functionalities to perform operating system dependent operations. So these operations include creating directories, creating, renaming and removing files and many other tasks. And these are the different methods we've got. So we've got os.rename, os.open, os.list directory, os.make direct, os.get current working directory and os.fdopen. Now to work with the OS library, we'd have to launch the Jupyter notebook. So we can either launch the Jupyter notebook through Anaconda Navigator or we can launch it through the Anaconda prompt. So Anaconda Navigator basically provides you a GUI. So you can either use this or the Anaconda prompt. Now when you open the Anaconda Navigator, you have Jupyter notebook inside this and all you have to do is click on launch. Now once you do that, you have your Jupyter notebook right in front of you. So over here, you'd have to click on new and open up a new Python notebook. Now once you do that, you have a new page and over there you'll be performing different operations. So your first task would be to import the OS library. So you'll just type in import OS. Now if you want to have a glance at the current working directory, all you have to do is type in os.get current working directory and it will give you the current working directory. And if you want to create a new folder, then you'll type in os.make dirs and then you will give in the path. After that, you will give in the name of the directory which you want to create. So let's perform this. So again, I'll just type in Anaconda prompt over here. Now inside this, I'll type in Jupyter notebook. Right. So now we see that we've launched the Jupyter notebook over here. Now I'll click on new and I'll open up a new Python 3 notebook. So our first task was to import the OS module. So I'll type import OS and I've successfully imported this module. So as I stated in the PPT, the OS module is basically used to work with different operating system applications. So you can create different directories, you can open up new files, you can rename files and so on. So our first task over here is to have a glance at our current working directory. So I'll type in os.getcwd and I'll put in the parenthesis over here. Right, so this is my current working directory, C users Intellipaat. Now I want to make a new directory in my C drive. So this would be the command for that. So I'll type in os.make dirs and over here I'd have to give in the path. So I'll type in C:/ and I'll name the folder as, let's say, new folder. Let me click on run. Right, so now I've successfully created this folder. Now let me actually go to the C drive and see if this folder exists or not. So this is my C drive over here, and I see that we have this folder with the name new folder. Now we'll go ahead and perform some more operations. So let's say I want to open a file which is present in my system. So to do that, I've got this command os.open, and inside this I will give in the path of the file, and then I'll give the name of the file. After that, I also have to give the extension of file, right? So this is a text file, so I'll type in file.text. And over here, this is basically the flag. So over here, I'd basically be setting what sort of operation I want to do. So O_RDWR, it stands for read and write. So I've got different operations. So I can open this file in only either read format or write format or read write format. Now, after that, we set in another parameter over here, which is os.o_create. So this means that if a file with the name file.txt doesn't exist, then it'll automatically create this new file and then it'll open it up. And then we've got another operation. So if I want to have a glance at all of the contents which are present in a folder, then for that the command would be os.list_dir, and I will give in the path. So over here I want to have a glance at all of the contents which are present in the D drive. So I'll just give in D over here. So these are all of the contents which are present in the D drive. Right, so now I'd want to open this sparta.txt file using the OS module. So let me do that. So the command was os.open, and inside this, as we saw, first we'd have to give in the path. So let me copy the path over here. I'll click on properties. I'll copy all of this and I'll paste it over here. You'd have to keep in mind that you'd have to give in / over here. So the path over here. So to separate all of these, you'd have to give in a /. Again, you'll give in a / over here, and then you will give in the name of the file. So the name of the file is sparta.txt. After this, I'll give in the flag over here, which would be os.o_, it'll be read and write. And then I'll give in the pipe operator. So over here, I'll just state if the file doesn't exist, then I'll tell the operating system to create it. So os.create, I'll click on run. Right, so we have successfully opened this file. Now I'd want to have a glance at all of the contents which are present in the C drive. So I'll type in os.list directory, and inside this I'd have to give in the path. So I'd want to have a glance at all of the contents which are present in the C drive. Right, so these are all of the folders or all of the contents which are present inside the C drive. Then I have a couple more commands over here. So this is the command to change the working directory. So over here I am changing my working directory from D drive to my folder. So I just have to give in the path for this, and this is how I can change the current working directory. And then we can also change the name of a file. So let's say if the name of the file was oldfile.txt, then to rename it, I'll just give in newfile.txt over here. So let's perform both of these operations. So let me perform both of these operations over here. So I'll type in os.chdr, and inside this I'll set the working directory to just C drive, C://. Right, I've changed the working directory. Now let me also check the current working directory now. Right, so now I've changed the working directory to C drive. Now let me go ahead and rename a file over here. So I'll type in rename. So over here this takes in two parameters. First is the path where the file is located and the name of the file. So I'd just rename this file over here Sparta. Right, so as we saw earlier, the name of the file was sparta.txt. Let me also remove this over here. Let me just put in a single quotation mark. Now after this I'd have to rename this. So I'll copy this all again and I'll paste it over here. Now I'll change this to Sparta new. I'll click on run. Right, so now we see that we've got a new file over here. So initially it was sparta.txt. Now we've changed it to Sparta new. Right, so that was the OS module. So the OS module, we saw how can we create new directories and how can we change the names of some files. Now we'll go ahead and do some proper file handling in Python. So the IO module is the default module in Python that is used to perform file handling operations. And it contains functions that return a file object called handle, and this handle is then used to read from a file or write to a file.
Just a quick info, guys. Test your knowledge of NLP by answering this question. Which of the following includes major tasks of NLP? A. Automatic summarization. B. Discourse analysis. C. Machine translation. D. All the mentioned above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So this is the command to create a file object. So we'll be using this function from the IO module. So open, and this has two parameters. So this is the first parameter, file, and over here we'll given the path of the file or just the name of the file. After that, we've got the mode. So over here, this mode basically specifies the way we want to open a file. So we've got these different modes over here, R, R+, W, and W+. So R basically stands for read-only mode, right? So if we open a file in read-only mode, then we can't edit it. So it's only read-only mode, and it starts from the beginning of the file. After that, we've got R+, which stands for read and write mode. So over here, the file pointer again starts at the beginning of the file. And with this, we can read the file as well as write something in the file. Then we've got W, which stands for write only mode. And even this, the pointer starts at the beginning of the file and it starts to overwrite the existing file. Then we've got W+, which allows us to write and as well as read. Now this doesn't start from the beginning, but it actually starts at the end of the file, right? So we can start writing from the end of the file over here. So these are the different modes which we can open a file. Now these are the different methods from the IO module with which we can read from a file. So now let's say we've opened up a file. So open, and then I'll give in the path, and I'm opening this in read only mode. Now I'll store the file in this F1 instance over here. Now if I want to read the entire file, I'll just type in f1.read over here. So this would give me the entire file over here. Now instead of reading the entire file, let's say if I want to read only the first line over there, then what I'll do is I'll type in read line. So I'm storing this file object in this F1 instance over here. After that, I'll type in f1.readline, and this would just give me the first line over here. So let me perform these two operations. Right. So I'll type in import IO over here. Let me load this up. Now I'd have to open the file. So open, I'll take the path. So I want to open up the same file, which is sparta.txt. Right, now I want to open this in read only mode. So I'll type in R over here. Right, so I've also given the mode. Now let me click on run. Right, so I've created an instance of this file. Now let me go ahead and read the contents of this file. So I'll type in f1.read. So these are the three lines which are present in this file. This is Sparta, this is 300, and this is Intellipaat. So let me just verify this. I'll open up this file, right? So these are three lines. This is Sparta, this is 300, and this is Intellipaat. Now, as you see, all of these three lines are separated by /n. So over here, /n denotes a new line over here. Now, instead of reading all of these three lines, I want to read only the first line from this file. So the command for this would be os.readline. Right, so now let me click on run. Right, so I've just read one line from this entire file. Now we'll see how to read a file line by line using for loop. So again, first we'd have to open up the file and save this file in an instance. So over here I'm saving this in F1. After that I'll start the for loop. So over here I'll create a new variable. So for line in F1, and this line stores every line which is present in this file over here. So it'll store the first line, and then we are printing the first line. Now once that is done, it'll go back and then print the second line, and it'll go back and then print the third line, right? So this is what happens. Now after we print all of the lines, I'm just typing f1.close. So when I type f1.close, it'll just clear all of the buffers and close the file. So I'll just type in for line in f1, and over here I want to print f1, right? So let me start off by using the for loop. So I'll type in for line in f1, and I'd have to print each of the line. So I'll type print line, and I'd have to close the buffer. So f1 dot close. Let me close this. Now let me click on run. Right, so let me start off by using the for loop over here. So I'll type in for line in f1. So this is f1 and not s1. I'd have to print each of the lines. So I'll type in print line, and then I'd have to close the file. So I'll type in f1 dot close. Right. So let me run this. Right, so I've extracted each of these lines with the help of the for loop. So we've got this is Pada, this is 300 and this is Intellipaat. Now let's see how can we write something to a file. So to write something to a file, we can use the write method. So again, we'll have to start off by opening the file. But this time we'll be opening this in write mode. So over here, I'll set mode is equal to W. And while writing, I also have to set the encoding type. So the encoding of this file is UTF-8. And what I'll do is, I'll add 3 new lines over here. So I'll type in, this is the first line, this is the second line, and this is the third line, and these 3 would be added to this current file. Now instead of adding one single line, let's say if I wanted to add multiple lines over here. So for this, what I'd have to do is, I'll create a list, and inside this list, I'll separate these 3 items with the help of /n. So as we already know, this /n, it denotes a new line. Right, now after that, we'll open the file. And over here, we'll open this in the mode A+. So A+ stands for the append mode, and we'll write this entire list into the file over here. Now let's perform these operations. Right, so what I'll do is I'll copy the same command over here and paste it over here. So the file would be the same. And over here, I'll set the mode to be equal to W. So W stands for write, and after this, I'd have to set the encoding. So encoding would be equal to UTF-8. So I'll type in UTF-8 over here and I'll click on run. Right, so I've successfully opened this file in write mode. Now I'd have to go ahead and write something into this. So I'll type in f1.write over here and let me write something inside this. So let me add the first line over here. So the first line would be this is 1. I'll click on run. Then I'll type, let's say, f1.write and I'll type this is 2. I'll click on run again. Then I'll type f1.write and I'll add the line this is 3. Now let me go ahead and open the file. So this time I'll open the file in read only mode. So I'll set this mode to be equal to R and I'll remove the encoding from over here. I'll click on run. Right, now I'd have to type in f1.read. Right, so this is what I have. This is 1, this is 2 and this is 3. Right, so I've successfully added these 3 elements into my file. Now as you see over here, my file initially had these 3 lines over here. This is Sparta, this is 300 and this is Intellipaat. Now when we use the write mode and we entered these 3 lines, this is 1, this is 2 and this is 3, what it did was it replaced these 3 lines with this. And this happened because the pointer starts at the beginning of the file. And when the pointer starts at the beginning of the file, all that which was there initially, that would be replaced. So let me go to the file now and see how it looks like, right? So I have a single line now. This is 1, this is 2 and this is 3 because the earlier thing was replaced. Now I'll go ahead and actually create a list over here. So I'll name this as L1 and I'll add some values over here. So let's say the first value is A. I'll add a new line after this. Then the second value is B. Again, I'll add a new line after this. And then I'll add a new value which is C. After that, I'll add a new line. Now I'll open this file in append mode. So this would be the same. The mode would be A+. And I'd have to give the encoding again. So encoding would be UTF-8. Right. So this time I've opened the file in append mode. Now what I'll do is I will go ahead and add this. So f1.write lines and inside this I'll just put in L1. Now I'll go ahead and open the file. Let's see what do we get. So I'm opening the file in read mode now. Now let me read what we have in this file. So now I have successfully added these 3 characters over here, A, B and C. So now let me open the file, right? So this was the first line. After that I added A, B and C. Alright guys, now let's see how can we work with Word document files. So we have this library with the name Python docx and we can use this for creating and updating Microsoft Word documents. So to install this library, we'll again have to go to Anaconda prompt and inside Anaconda prompt we'll given this command conda install -c conda forge Python docx. Right, so with the help of this command, we'll be installing Python docx library. So once the installation is done, we'll go to either Anaconda prompt or Anaconda navigator and then launch the Jupyter notebook. So we'll open a new notebook over here, new Python notebook, and we'll type in import docx. So here you have to keep in mind that when importing the library, you'd have to type docx and not Python docx. So you'll type in import docx. So once you import the library, now let's see how can we create and update a Word document. So starting off, we'd have to create an instance of our Word document. So to create an instance, we'll invoke the document method. So we'll type in docx.document and we'll create an instance of the Word document. So I'm naming this instance as document. Now once we have this instance, we can add all of the content into our Word document. So I'll type in document.add heading, and with the help of this I can add a heading to my document, right? So over here I'm adding the heading. This is a 0 level heading. So here 0 indicates the level of the heading, right? So once we add the heading, now we are going ahead and adding a new paragraph. So here I'm typing document.add paragraph and I'm just writing this is a paragraph. And after that, if I want to add a page break, so we can use this method document.add page break. So we created an instance, and with the help of that instance, we added a heading and we also added a paragraph. Now it's time to save the document. So to save the document, we'll type in document.save, and inside this we'll give in the name by which we want to save the document. So I'm saving the document as document.docx, right? So this is how we can create a document. Now let's see how can we read a Word document. So to read a document, we'd have to start off by importing this document method from docx, and then we'll use this document method, and inside this we'll pass in the name of the document. So we'll pass in document.docx, and this is the file which we had just created earlier, and we'll save this in a new instance and name that to be doc. So once we have this instance over here, we'll use the for loop, and with the help of this for loop, we'll print all of the content inside this document. So I'm typing in for para and doc.paragraphs, print para.text, right? So it'll take in each paragraph over here and it will print each paragraph with the help of this for loop. Right, now let's go to Jupyter Notebook and actually perform this. So I'll start off by importing the library, which is docx. So I'll type in import docx. Now I'll go ahead and create an instance of this. So docx.document, and I'll name the instance as doc. So now that I have the instance, I can add the content into this. So I'll type in doc.add heading. Now let me add the heading. So I'll just say heading 1 over here, and then I'll add a couple of paragraphs. So this time doc.add paragraph, and inside this I'll type in p1, and then I'll add another paragraph. So I'll type in doc.add paragraph again, and I'll add p2 inside this. After this I'll add a page break. So I'll type in doc.add page break, and I'll click on run. Now after the page break I'll give another heading. So doc.add heading, and I'll give the heading as heading 2. So all of this is done. Now it's time to save this document. So I'd have to type in doc.save, and I'll give the name of the file. So I will save this as, let's say, my doc.docx. Right. So now I have successfully saved this file. Now it's time to read this document which I've just created. So I'd have to import document. So I'll type in from docx. I'd have to import document. Right, so now that I've imported this, so I'll just give in the name of the doc which I've just created. So my doc.docx, and I will store this in a new document again, and I will name this as d1. Right, so now I have created a new instance of the document which I had created earlier. Now I'll use the for loop. So for para in d1 dot paragraphs, and I'll just print this out. So print a para dot text. So now we have the content which is present in the document over here. Heading 1, para 2, and then we added a page break. After that we have the heading 2. Right, so this is how we can work with the docx module. Now let's head on to the natural language toolkit. So NLTK is one of the most widely used packages for the purpose of natural language processing. So NLTK provides multiple packages to perform different operations such as tokenization, POS tagging, named entity recognition, and sentiment analysis. right? So NLTK provides very easy to work with modules, and with these modules, all of your work becomes much more organized and much more easier. Now again, let's see how can we install the NLTK package. So again, we'd have to go to Anaconda prompt, and we'll give this command inside Anaconda prompt over here. So we'd have to type in conda install -c Anaconda NLTK, and this is how we can install the NLTK package. Right. Now once we install the NLTK library, we have something known as the NLTK Corpora. Now you must be wondering what exactly is a corpora. So before understanding corpora, let's understand what is corpus. So a corpus is a huge collection of written text, and a compilation of these corpuses is what is called as a corpora. Now NLTK provides this huge corpora for multiple purposes. So it has got all of these different corpuses pertaining to different domains, and we can use it to perform various NLP tasks. Right, now let's see how can we download this NLTK Corpora. So once we install NLTK, we'll have to go to Jupyter Notebook and then type in import NLTK. And then after that, we just have to type in nltk.download. So this would give you a setup wizard. Now all you have to do is click on download, and this will install all of the corpuses which are present in NLTK. So this is how you can import a corpus from NLTK. So there's this corpus with the title names, and we are importing this corpus. So I'll just type in from nltk.corpus import names, and this just has a list of all of different words. So to have a glance at all of those words, I'll type in names.words. Right, now let me go to Jupyter Notebook and just show you how can we do this. Right, now let me start off by importing NLTK. So from nltk.corpus, what I want is names. So this is basically the name of the corpus which you are importing. Right, now I've imported this corpus. Now I want to have a glance at the list of the names which are present. So I'll just type in names.words and I'll click on run. So this is the list of the names which is present inside this corpus.
So after understanding the different syntactic categories of a sentence, now we'll move on and understand what is chunking. Till now we have studied that how to extract sentences, words, even symbols and letters from a sentence using tokenization, and we've also seen how to attach part of speech tags to those words. The next step in understanding the meaning or the syntax of a sentence is to know what the syntax is talking about, or we can say the subject of the syntax. So for that we use a concept called chunking, where we'll chunk different words and we'll understand what the sentence is talking about. So it is an NLP technique which is used to group words or tokens into phrases in order to analyze the structure and meaning of a sentence. So the grouping of the words is based on the POS tags, and we can also group different phrases from a sentence. So if you have a sentence that has different words, so these boxes represent different words, and now you know that how to tokenize, how to extract these words, individual words. So now after that we'll understand how to extract group of words that convey any meaningful information to us. So we have a noun phrase which can contain a noun, an adjective and a determiner. So adjective and a determiner are optional, so it can contain a noun or a pronoun. And then we can have verb phrases in our sentences which contain a main verb, a helping verb, or any modifier. So it can be an adverb. And we can have different noun phrases, multiple noun and verb phrases. So in noun phrase we actually have the noun and we can know what our sentence is talking about. We can chunk different phrases from a sentence. The first we'll know how to chunk noun phrases, and then we'll see how to chunk verb phrases, adjective phrases that contain an adjective, and prepositional phrases that contain a preposition or an optional object and its modifier. So we can chunk all of these phrases from a huge sentence to understand the meaning of the syntax and syntactic structure of the sentence. So to start with, we will firstly understand how to chunk noun phrases from a text. First step is we have to import the word tokenize, so that we tokenize every single word, and then after tokenizing we'll attach the part of speech tags of every word, and using those part of speech tags we'll chunk a group of words as a noun phrase from our sentence. So here I've imported the word tokenize function from nltk.tokenize, and then this is our sample text that we'll chunk our words from. We'll tokenize the words and then we'll chunk different phrases from this sentence, and then after performing the word tokenization, we have different words that are present in our text. The next step is to attach a part of speech tag to each word present in the text so that we can chunk later on. So after using the POS underscore tag function, we'll tag each and every word with its respective part of speech, and when we print, every word will be having a part of speech. The here is a determiner, and JJ, which means an adjective. So our crazy is an adjective. Brown is a noun. Here it is classified as a noun, and dog is also a noun. And then we have a VB, which means verbs, different tenses of verbs, and we have interjection, determiner, nouns. Based on these part of speech tags, now we'll see how we chunk thus noun phrases from our sentences. To perform chunking, we'll use both part of speech tags and regular expressions. So using regular expressions, we'll extract different chunks, or we'll define different patterns that suit a particular chunk. So we have defined a regular expression that will be used to chunk all the noun phrases from our sentence. Regular expression will chunk the NP, so we can write anything here. So I've written NP, which is a noun phrase, then it's colon. So after the colon, we have to mention our regular expression inside these braces, and the first word that it will chunk should be a determiner. We have to put it inside these brackets, and DT is for determiner, so the is a determiner. And then we have a sign of interrogation, which means either 0 or 1. In a noun phrase, there can be either a 0 determiner, no determiner, or only 1 determiner in the beginning. And the next word, it can be an adjective. This means 0 or more, this asterisk. In our noun phrase, there can be either 0 or more than 0 adjective. And the third word is a noun. There can be either 0 or 1 noun. So if there is any noun, so it will be extracted. And if there is any noun and in front of it there is an adjective, so that word will be extracted. And if there is a noun and in front of it there is an adjective and a determiner, all these three words will be extracted. Based on this regular expression, when we use regular expression, we have to import the regex parser class from NLTK. So I'll write from NLTK import regex parser, or if you have imported NLTK already, so you can use along with the NLTK, and you have to pass your regular expression, which I have stored it in grammar. So when you pass your regular expression to regex parser, we'll create an object of this class, that is chunk parser. So after creating the object of this class, we'll use the dot parse method of this object to parse our sentence. Once we parse our sentence, so in the regex parse dot parse, we have to pass our POS tags. So this will be all the words along with their POS tags. So when we pass our words along with their POS tags to our chunk parser.parse, all the words will be chunked and will be stored in tree. So once we print the tree, now you can see this is our sentence, and the first noun phrase, this is NP. The noun phrase it contains a determiner, the, and an adjective, that is crazy. And then we have two nouns, that is brown dog. And apart from that, these are verbs. So these are not chunked because we have not chunked the verbs till now. And then we have another verb that is running, and then we have an interjection, that is through, and then after that we have another noun phrase, that is NP, denoted by NP, and it contains determiner, that is the, and a noun mud. In this noun phrase there is no adjective, so there is only one determiner and one noun. We can represent this chunking using a tree, so that makes it visually easy to understand. So we'll draw the parse tree that we have seen before, which is also called a syntax tree. So for doing that, you just have to use this variable, that is tree, and the draw method of this variable. So once you run this line, there will be automatically a new window popping up that will show your syntax tree. So you can see this was our sentence: the crazy brown dog went running through the mud. And we have two noun phrases in this sentence. So the first noun phrase, it contains a determiner, the, an adjective, that is crazy, and two nouns, that is brown and dog. And then we have another noun phrase that contains a determiner and a noun. So we have two noun phrases in this sentence, and we have successfully chunked these two noun phrases from our sentence. So now we'll chunk another set of phrases using another regular expression. So I've defined my sample text as the term 5G refers to the 5th generation of mobile technology, which promises of faster browsing, streaming, and download speeds, as well as better connectivity. The first step is to tokenize all the words present in this sentence. So for that, I've used the word tokenize function. on the sample, and all those words are extracted as tokens and stored in this list. So now our next step is to attach a part of speech tag to every single word. So we'll use this part of speech tags to create chunks and extract them from our sentence. To attach part of speech tags, we'll use the POS underscore tag function, and we'll pass our tokenized words. Once we pass our tokenized words, all the words will be labeled with a part of speech tag. You can see that there is a determiner, and then we have nouns, cardinals, which is a number, and another nouns and determinants, adjectives. Now we'll use another regular expression. So we'll chunk different phrases from this sentence. So here we have defined a regular expression that will chunk these two phrases from our sentence. So we have written the name of the chunk as NP. So it will first of all check if there is a determiner or a prepositional phrase till the end of the line. So this $sign means end of the line. So it will check every word till the end of the line if it is a determiner or a prepositional phrase. And then we have added sign of interrogation, which means 0 or 1. So either this part can be 0 or 1. And then we are searching for an adjective. It will be asterisk means 0 or more. So 0 or more adjectives, and then one noun is mandatory, that is NN. And then it will also search for this part, which is at NNP, which is a proper noun. So it will search for NNP, and the plus sign means that it will search for one or more. So there can be minimum one NNP or one or more NNPs, that is proper nouns. So it will check chunk, determiner, possessive, adjectives, and a noun, and then we have chunk sequence of proper nouns. Once we define this grammar or this regular expression, so we'll pass this regular expression to our regex parser. So once we pass this to our regex parser class, so our object is created. So we have stored the name of the object is chunk parser. So now we'll use the dot pass method of this object to parse our text. So the text that we need to pass is our text that contains the words along with their part of speech tags, because our text are matched with this regular expression, and then all the phrases or words that match this criteria will be chunked. And then we have stored it in tree variable. So once we print the tree, I will see that the first NP, which is our chunk, has one determiner and then one noun. And after that we have another noun phrase, that is determiner, then adjective, and then noun. And then we have another noun phrase which is only proper noun, that is mobile, according to this regular expression. And then we have another noun phrase that has only technology, which is another according to this expression. There is only one noun in there. We don't have any adjectives or determiner and prepositional phrases. And then we have another noun phrase here and another noun phrase. This is how we'll chunk based on the POS tag values from our sentences. So now if we draw the parse tree or the syntax tree for the same sentence, for the same chunks that we have extracted here, so we'll just have to write the tree.draw attribute, so our tree.draw method. So once we run this, all the NPs which is the name of our chunk, they will be extracted from rest of the sentence. So now we'll see how to chunk verb phrases from a sentence. So I've defined a sentence sample which says he should wait before going swimming. So this is my sentence. Next two steps are to tokenize the words and then to attach part of speech tags to every word. So I've done that in one step, that is NLTK.word tokenize sample, and then I'll attach the part of speech tags to every single word, and then we have stored the word in POS text. So once we print this, we'll get all the words along with their part of speech tags, and then we have to define regular expression that we'll use for matching the words and chunking the words. Define the regular expression here, which will chunk all the verb phrases from the sentence. The first word of that verb phrase should be a personal pronoun, and this sign of interrogation means it can be either 0 or 1 in number. And then the next word is a verb, so it can be any one of these verbs. So the VB is the base form of a verb, and then we have VBD, which is the past form of a verb, and then either it can be VBZ, which is a third person singular present form, third person singular. And then we have VBG, which is the present participle form of verb. So it can be either one of these four, and the asterisk means this can be either 0 or more than 0. And then the third word can be an adverb, so RB means an adverb, and then or it can be adverb which is comparative form. So comparative forms such as better, greater, taller. So it can be an adverb. And then sign of interrogation means it can be either 0 or 1. We'll chunk all these words in verb phrase from our sentence. So after defining our regular expression, now we'll use the regex parser class to create an object. So this class will take our regular expression as an argument. The object that we created is chunk parser. So after we create an object chunk parser, we'll use the dot parse method of this object to create chunks from our sentences. So we have to pass the POS text list which contains the words along with their POS tags. So we have stored it in tree. Once we get our tree variable, now we'll print tree. So once we print the tree, our first verb phrase is this one, he. So he is a personal pronoun. So this was the only one verb phrase. So this will be chunked. And then the next verb phrase that will be chunked is wait, which is the base form of verb. And then we have going, which is the present participle. So it will also be chunked. Once we draw the parse tree for the same sentence, so this is our sentence, and then only the verb phrases are chunked. So the first verb phrase is he, the next verb phrase is wait, and the third verb phrase is going, which is the present participle form. Let's go to the Jupyter Studio now and implement chunking, and we'll see how we chunk different phrases from our sentences. Now we'll see how we chunk noun phrases from this sentence. So I've written a sentence, the dark cloud covered the sky. The first step would be to tokenize all the words and attach a part of speech tag to every single word. So I'll store that in POS list. Once I run this line, all my words will be tokenized and a part of speech tag will be attached to every single word. So if I run POS now, so you can see that every word has been attached a part of speech tag. So now based on these tags, we'll extract all the noun phrases that are present in this sentence. So for that, I'll define a regular expression. So I'll store it in regex, and then R is for mentioning that it is a regular expression. So I'll name of the regular expression, the name of the chunk that I'll keep is NP, and then we have to define our tags we want. First word can be a determinant, and there can be either 0 or 1 determinant. For that, I'll write sign of interrogation, and the next word can be adjective that can be 0 or more. So for 0 or more, I'll write asterisk, and the third word should be a noun, and they can be 0 or more nouns. So you can write this. So after writing this, when I run this, my regular expression is created. Now I'll use the regex parser class to parse this regular expression and then extract all the noun phrases from the sentence. For that, I'll firstly define the instance of my regex parser class, and I have to pass my regular expression as an argument. So once my object is created, now I'll use this object to identify all the noun phrases from my sentence. So I'll just write dot parse method, and I'll pass my POS words list, and I'll store this in tree. Once I run this, now I'll print my tree to see how many noun phrases are there. So you can see this is our sentence, and we have the first noun phrase, the dark cloud, and then we have another noun phrase that is the sky. Now let's print on the parse tree for this. Once we run this, we'll get a tree which identifies all the noun phrases that are present in our sentence. So we have the dark cloud, this is a determiner, this is an adjective, and this is a noun. And then we have a past form of verb, and then we have a determinant and a noun. So this is also a noun phrase, and this is also a noun phrase. So we have successfully chunked 2 noun phrases from our sentence. So now let us extract different phrases from this sentence given here, that is Mary saw a cat sitting on the mat. So the first step will be to take all the part of speech tags words. So I will just use these 2 functions. So once I run this, now my words along with their part of speech tags will be stored in POS list. So now I can create a regular expression. This is my regular expression that I have created. So here we are chunking all of these words, all of these phrases. First we'll chunk the noun phrases. So we have a determiner 0 or 1 times, and then an adjective 0 or more times, and then a noun. So the noun can be in any form. So it is NNP or NNS. Then for any word after NN and 0 or more times, If we just write NN, only NN nouns, singular nouns will be extracted. If you write this one, so all of the nouns will be extracted. And then we have defined how to extract preposition, that is just IN for preposition. POS tag is IN. And then to extract verbs, so if you want to extract VB, VBZ, VBG, so you have to write this code, because after V the point means any word after V, and that is 0 or more times, so it will extract all the verbs. And then to extract prepositional phrases, we have used PP, that is preposition which is IN, which is defined here, and a noun phrase which is defined here. And then to extract verb phrases, we have used VP, that will be any verb which is defined here V. And then after that there can be a noun phrase or a prepositional phrase 0 or more times, so that is optional. Once I run this code, so my regular expression will be created. Now I'll use parser to parse this regular expression. So once I run this code, now my parser is ready. Now I'll use the dot parse method of this parser to chunk all the phrases that I've defined in my regular expression. So I'll write, and then I'll pass my POS words list. I'll store it in tree so you can print it. So after that I'll print the tree. So now you can see that from our sentence, Mary, which is proper noun, has been chunked as noun phrase. Then we have verb phrase, then another noun phrase, and then verb phrase, and a prepositional phrase, and then a noun phrase. So it is better if you visualize this to see how it is chunking. Just write tree dot draw to draw the parse tree. Here we have the parse tree for this sentence. So you can see from our sentence, first noun phrase is Mary. Then we have another noun phrase, that is saw, which is the past form of verb. And then verb phrase contains a verb and a noun phrase here. So then another noun phrase we have is a cat. So a is a determiner, and then cat is a noun. And then we have third verb phrase, which also contains a verb and a prepositional phrase. Verb is the present participle form, VBG, sitting. And then we have a prepositional phrase which has one preposition and one noun phrase. So the preposition is on, and the noun phrase is the man. So this is how we draw a parse tree, and we have extracted noun phrases, verbs, prepositions, verb phrases, and prepositional phrases from a sentence.
Just a quick info, guys. Test your knowledge of NLP by answering this question. To which of the following fields does NLP belongs to? A. Computer science. B. Artificial intelligence. C. Linguistics. D. All of the mentioned above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session. Just a quick info, guys. Intellipaat provides NLP training using Python mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
So after understanding about chunking, now let's move on to understand what is chinking. Many a times while chunking, we end up with chunks that we actually do not need in our chunks. So to exclude specific phrases from our chunks, we have a concept called chinking. So chinking is used to exclude a specific chunk from the whole chunk, and we can define chink to be a sequence of tokens that we don't want to be included in our chunk. For example, we have noun phrases, verb phrases that we have chunked. So if we don't want verb phrases or any specific verbs, specific type of verbs, then we can define how can we chink those verbs by using chinking. To implement chinking, we will first import word tokenize to tokenize all the words, and then we have defined a simple text that we'll use for chinking, and then the sample text is tokenized, and a part of speech tags are assigned to each and every word that is present in the text, and we have printed it. These are all the words along with their part of speech tags. So now we'll define which words we do not want from in our chunk. For that we have defined a regular expression. So here is our regular expression. So our name of the chunk will be chunk, and first of all we'll chunk everything using the braces. The dot means any word, and 0 or more of any word. Then we want 1 or more of any word, so it means it will chunk every word that is present in the sentence. And then to perform chinking, to exclude a specific tokens or specific words from our chunk, we just have to invert the braces here. So if you just invert the braces and mention the tokens that you do not want in your chunk, those particular tokens will be chinked. So you just have to mention all the tokens that you do not want to be chunked. So I have mentioned the first token to be a verb. It can be any verb, any form of verb. It will be VB and also VBZ, VBR, VBG, because I've inserted a dot, so it means even if any word is after B, that verb will also not be chunked. And then sign of interrogation means 0 or 1. Then or we have 4 tokens, so if any one of these tokens is found in the sentence, these will not be chunked and rest of the sentence will be chunked. And then we have a preposition and the determinant and the to word. So if there is a to word going to, so that will be a to word, and we want one or more of these, there will be at least one word that will not be chunked, so it will be either one of them. And then after defining the regular expression, we can use our regular expression regex parser class to parse our grammar or our regular expression. And then once we create an object of this class, we can use this object to parse our words and to find chunks from our sentence. So we'll use the object and the dot parse method of that object, and we'll pass our text that has words along with the part of speech text, and we'll store it in tree. Once we print the tree, we'll get sentence, then whatever the words that will not be chunked, and we'll get only the chunks where the words that we only want to be chunked. So the determinant which was mentioned in the chink regular expression, this word is not chunked, and our verbs you can see and our preposition are not chunked, and whatever is left after these words, those words are all chunked. So let's see a parse tree of this to understand it better. So here you can see that this is a whole sentence. Only the words which do not include determinant, verbs and prepositions, they are not, only those words are chunked and these words are not chunked. Now let's go to the Jupyter notebook and implement chinking on a sample text. So we have a sentence here. The little yellow dog barked at the cat. So we'll see how can we chink certain phrases from these words to extract only the phrases that we require. If I only want the noun phrases from this sentence, either I can define a noun phrase, but if my sentences are huge and if I know there are certain words that I don't want from the sentence, then I can directly exclude those words using chinking so that I only get the noun phrases. First of all, we'll tokenize the words from this text, and then we'll attach a part of speech tag to every single word, and I'll store it in POS. So after running this, all of my words, they are stored along with their part of speech tags. So if I only want noun phrases, so I can either define noun phrase or I can chunk certain phrases so that I'm only left with noun phrases. This is my grammar that I'm going to use, so I'll store it in regex. So we'll define it by R, and then I'll define the chunk that I want. First of all, we'll chunk everything using this expression. And now once we chunk everything, now if I want to exclude the verbs and the prepositions from this text, so I'll invert the braces. After inverting the braces, I'll write my regular expression that I want to chink. So I want VBD, the verb form, which is the past form of verb, and then either it will chink this one, or if it finds a preposition and one of more, so either one of these or more than one of these will be chinked from the whole sentence. So once I run this, my regular expression will be created. Now I'll parse my regular expression using the regex parser. So I'll store it in parser object, and I'll pass my regular expression in this, which is regex. So after this, I can parse my sentences and I can chunk and chink everything that I want. So I'll store that the chunks and chunks in the tree, and I'll use the parser object along with the parse method, and I'll pass my tokens which already have a part of speech tag to them. So I'll just write POS. So now if I print my tree, so you'll see that VBD, which is the past form of verb, and preposition have been chinked. They are not included in the chunk, and rest of the words are included in the chunk, which are actually the noun phrases. So let's draw the tree. So here's the tree that we got. So we have chinked these two words from the whole sentence. So first of all, we chunked all of the words, and then we chinked these two tokens, and we are only left with the noun phrases.
So why AI? Well, AI is actually everywhere. It's omnipresent like God.
And AI's applications are present in every single industry, from banking and finance to medical science and also in aerospace. Now, it is actually a known fact that many banks have numerous activities on a day to day basis which need to be done accurately. And most of these activities take up a lot of time and efforts from the employees, and at times there is also a chance of a human error in these activities, so to speak. So, some of the works that banks and financial institutions handle are investing money in stocks, financial operations, managing various properties, and so on. And with the use of AI system in this process, the institutions are able to achieve efficient results in a quick turnaround time. So, the strategic implementation of artificial intelligence in the bank helps them to focus on every customer and provide them quick resolution. And similarly, in medical science field as well, it has wide applications. So, AI has completely changed the way medical science was perceived just a few years ago. So there are numerous areas in medical science where AI is used to achieve incredible value. So with the help of AI, the medical science was able to create a virtual personal healthcare assistant. So these are used for research and analysis purpose. There are also many efficient healthcare bots introduced in the medical field to provide constant health support to patients, and it is also used in the aerospace industry. So in aerospace, there are a lot of features from booking the tickets to the takeoff and operation of the flights that AI takes care of. AI applications make air transport efficient, fast, safe, and also provides a comfortable journey to the passengers. And it has also changed the face of gaming. So these days we're able to play TV and computer games on the whole new level, all thanks to artificial intelligence application. So these are just some of the applications where artificial intelligence is used. And all in all, it is used to reinvent the world. So scientists are riding on the back of AI when machine intelligence will surpass the human intelligence. Scientists believe that once the AI system starts working in its full capacity, it will reinvent the world that we know today. So think of the world where all the menial tasks such as garbage disposal, construction, digging, and so on will be taken care of by AI applications. So it'll all be a time when the hierarchical order dictates the limits of a human. It'll be the world where no one will be looked down upon and every human will be considered equal. So this way, humans can then focus their strengths on higher levels of work to accomplish a lot more and always taking technology to new heights. So now that we've understood the importance of artificial intelligence, let's learn more about AI. So AI is basically a field of computer science which emphasizes on the creation of intelligent machines which can work and react like humans. So I am reiterating it. So AI is that field of computer science where we create machines which can work and react like humans. So let's keep this definition at the back of our head. Using this definition, let's actually look at some applications of AI which are currently existing in today's world. So we have simple chatbots like OK Google and Siri which help us in assisting whatever we want. So let's say I want to know the current time. All I need to do is ask Siri, Siri, tell me what is the current time. Similarly, if I want to know the distance between India and Malaysia, I'll ask Siri, tell me what is the distance between India and Malaysia. Again, let's say I'm just sad and I want to listen to a simple joke. I'll ask Siri, tell me a simple joke. Alright, so these are some of the applications of artificial intelligence. And then we have Sophia. So Sophia is the first humanoid robot. So she is the first humanoid robot who can actually speak to us like natural humans. So Sophia can show some wide range of emotions exhibited by humans, but she is actually a robot. Another application of artificial intelligence is the self-driving car. So you have self-driving cars by Google and Tesla, which actually drive by themselves. So they do not need any external driver to drive, right? So these cars work by themselves. So similar to self-driving cars, we also have self-flying drones, which do not need any human intervention and they can navigate by themselves. So now let's actually get a bit deeper and understand what is intelligence. So intelligence can be defined as one's capacity for understanding, one's capacity for self-awareness, one's capacity for learning, and one's capacity for problem solving. That is, how well is something or someone able to understand? How well is someone able to learn new things? And how well is someone able to solve problems by themselves? So, now that we know what is intelligence, let's understand what is artificial intelligence. So, when you apply the same intelligence to machines, this is known as artificial intelligence. Now, just imagine there's a machine which can understand things which are normally understood by human. There is a machine which is self-aware, and there is a machine which can solve problems by itself. Now that's just amazing, isn't it? Right. So this is the artificial intelligence which I'm talking about. So now that we also know what is intelligence, I'll ask another question. So tell me, what is it that makes humans intelligent? Well, we as humans can reason, we as humans can learn, we can perceive, we can solve problems, and we also have linguistic intelligence. That is, we can figure out what is someone else saying, and we can also understand the grammatical intricacies of different languages. So, again, my question would be, what if a machine could exhibit all of these factors normally shown by a human? Again, that's just amazing, isn't it? So this is what is known as artificial intelligence. So a machine which can show traits normally shown by a human, that is known as artificial intelligence. Let's see different examples of machine learning around us. So most of you would have shopped on Amazon. Now, when you go into Amazon, you see that there are some products recommended to you. Now, how do you think that would happen? So this is something known as recommendation engine, and recommendation engine is nothing but a component of machine learning. So let's say you and your friend buy similar products. So your friend buys 5 products and you buy 3 products. Now out of those, whatever 3 products you buy are same as what your friend buys. So let's say the common products are an iPhone, a back cover for the iPhone, and a Bluetooth headset. Now, let's say the other 2 products bought by a friend would be a MacBook and a mouse. Now, since there are 3 products which are same between you two, this is why the products which your friend has also bought, those are the products which will be recommended to you. So, on the basis of the commonality between you and your friend, you will be recommended a MacBook and a mouse as well. So this is nothing but a concept of machine learning. And then we have Amazon Alexa. Amazon Alexa is a really good example of speech recognition. You know, when you say Alexa, turn on the lights, it'll turn on the lights. When you say Alexa, book a ride for me, it'll do exactly that. When you say Alexa, order a cheese pizza, and that is exactly what Amazon Alexa will do. Now, Alexa is just a machine, right? But when you say do something, order a pizza, book a cab for me, turn on the lights, how is the machine able to understand all of this? So, the idea behind this is speech recognition, and that is again a component of machine learning. And then we have Netflix's movie recommendation. So, let's say you watch 2 TV series. First TV series is Friends, and the next TV series is Big Bang Theory. And since you watch these 2 TV series which belong to the genre comedy, that is why maybe you will be recommended How I Met Your Mother, or you can be recommended Silicon Valley, or some other TV series belonging to the comedy genre. So this again is machine learning. And then we also have Google traffic prediction. Let's just say you're traveling in your car and there is huge traffic there. You desperately want to get out of the traffic. So you turn on Google Maps and Google Maps tells you the best direction from where the traffic would be the least. Now, how does Google Maps do this? This again is machine learning. So now that we've looked at different real world applications of machine learning, let's actually understand what exactly is machine learning. So, as I've already told you, machine learning is a subset of artificial intelligence which gives the machine ability to learn without being explicitly programmed. So over here, data is the key, or in other words, you basically teach a machine how to learn without any explicit programming, and the machine learns with the help of data. So let's just go through this simple video to understand more about machine learning. Right. So now that we know what exactly is machine learning, let's also understand how does machine learning work. So as I've already told you, machine learning depends totally on data. So first, we take in a data set and divide it into two parts. So the first part would be the training set and the second part would be the testing set. And we will train the model on top of the training set. So now once we train the model, we will give it new data and check for its accuracy on top of that new data. And if the accuracy of that new data comes out to be good enough, then we will go ahead and use that machine learning model. On the other hand, the model which you built, if the accuracy of that model is not good enough, then we'll go ahead and fine tune that model till we get the desired accuracy. This is the basic premise behind machine learning. Now let's look at the subcategories of machine learning. So we have supervised learning, unsupervised learning, and reinforcement learning. So in supervised learning, you can consider that the learning is guided by a teacher. So we have a data set which actually acts as a teacher, and its role is to train the model or the machine. So once the model gets trained, it can start making a prediction or decision when new data is given to it. So let's take this example. So over here, we are training this machine by giving it samples of data. So over here, the data is nothing but different images of apple, and along with each image of apple, we are also giving it the label of the image, right? So this image goes with its label, which is apple. Again, this image goes with its label, which is apple. Again, the same with these two, right? So we are teaching this machine that whenever it sees an image something like this, it is nothing but an apple. And after time, when we give it a new data from whatever learning it has done, it will predict whether it's an apple or not. So on the basis of its learning, this machine predicts that there is a good possibility. There is actually 97% possibility that the image which has been fed to the machine is nothing but an apple. So a use case of supervised learning could be spam classifier. So spam classifier basically means that whether the email which we get it's a spam or not, and that is done on the basis of different textual parameters. So let's say a genuine email wouldn't contain too many exclamation marks, it wouldn't contain a catchy headline and so on. But on the other hand, if it's a spam email, maybe it will contain a lot of exclamation marks with maybe a lot of numbers, and it'll have statements like, hey, congrats, you've won a lottery, or hey, could you help me out? So this spam classification is basically an example of supervised learning. Then we have unsupervised learning. So in unsupervised learning, the model learns through observation and finds structures in the data. So once the model is given a data set, it automatically finds patterns and relationships in the data set by creating clusters in it. So what it cannot do is add labels to the cluster. Like it cannot say this is a group of apples or mangoes, but it will separate all the apples from mangoes. So over here we have this set of images. Now this unsupervised learning model which is applied on this, it will segregate these fruits on the basis of similar characteristics. So over here we have segregated these 4 into one cluster, these 3 into second cluster, and these 3 into the third cluster. Now, even though the unsupervised learning does not have any labels, it has still segregated these 3 into 3 clusters, right? So the machine over here does not know that these are apples or these are oranges or these are bananas. Yet it has segregated these 3 on the basis of similarity of characteristics. So it found out that these 4 objects are similar to each other, and there is quite a bit of variability when it comes to these 4 objects and these 3 objects. Similarly, this machine was able to figure out that these 3 objects, they are quite similar to each other. But when compared with these 3 objects, they are very dissimilar. So this is the underlying concept of unsupervised learning. And a good example of unsupervised learning would be again Netflix movie recommendation. So over here, the movies are segregated on the basis of different genres. So over here, TV series like Friends, How I Met Your Mother, and Silicon Valley are clustered into one group because those come into the same category. Similarly, movies such as Secret Superstar and Dangal could come under the same category because they have the same lead actors. So over here, we are segregating the movies on the basis of similar characteristics, even though there are no labels in it.
Just a quick info, guys. Test your knowledge of NLP by answering this question. Which of the following includes major tasks of NLP? A. Automatic summarization. B. Discourse analysis. C. Machine translation. D. All the mentioned above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And it's finally time for the third machine learning type, which is reinforcement learning. So over here, there is an agent and there is an environment, and the agent interacts with the environment and finds out what is the best outcome for it. So it basically follows the concept of hit and trial method. The agent is rewarded or penalized with a point for a correct or a wrong answer. And on the basis of positive reward points gained, the model trains itself. So let's take this example. So over here, this self-driving car would be our agent and the road is the environment. And this car is interacting with this environment. So it will observe the environment and it has two choices over here. So either to go straight or turn right. Now, let's say this agent or the self-driving car decides to go straight. Then what happens is it goes and bangs straight into this barricade. So then it realizes that the action taken by it was not in its best interest, and that is why it is penalized. So since it is penalized, it realizes that the action taken by it was wrong, and that is why from the next time onwards, it will do the opposite action. So instead of going straight, it will take the right turn. And when it takes the right turn, it realizes that the road is correct and the agent is rewarded. So this is how reinforcement learning basically works. So the agent interacts with the environment, it takes an action, and if the action turns out to be incorrect, it is penalized. And if the action turns out to be correct, it is rewarded. So this cycle goes on and on till it completely learns its environment properly. And the best use case of reinforcement learning is again self-driving car. So companies such as Tesla and Google are working on these self-driving cars. So just to sum it off, these are the three different types of machine learning algorithms. So we have supervised, unsupervised, and reinforcement machine learning. So under supervised, we have regression and classification, and in unsupervised, we have clustering techniques, association analysis, and hidden macro model. And then the third is obviously reinforcement learning, which works on trial and error method. And if you want to do some really cool machine learning projects, you can check the sites out. Now let's look at some limitations of machine learning. So when it comes to machine learning algorithms, they would require massive stores of training data. So again, as I've told you, machine learning is totally based on the data which it has. So if you have more amount of data, only then it will be able to give correct accuracy. So let's say you take in very small amount of data, and there's a good possibility that the results which you're getting are very biased or very incorrect. And also, error diagnosis is quite difficult when it comes to machine learning, because again the amount of data is very huge, and wherever there's a mistake, you'd have to go through the entire algorithm which you've written and then find out that particular mistake by yourself, which is very difficult. And also when it comes to machine learning algorithms, they're not really that creative. So these ML algorithms are built only for one specific purpose. So let's say I'll build a machine learning model which will predict whether it will rain or not today. Now, if I want to use the same model to predict the stock prices, that will not work, right? So basically one model is built only for one particular task. So this is the lack of creativity that I'm talking about when it comes to machine learning. And also there are a lot of time constraints as the model has to learn through a lot of historical data. So that was everything about machine learning. Now let's start off with deep learning. So deep learning is a subset of machine learning where it learns through data representations as opposed to task-specific algorithms. So we saw that the drawback in machine learning models was that the models are specific to only one particular task. But this is not the case with deep learning models, as these deep learning models are based on the data representations. And these deep learning models are mostly built with something known as deep neural networks. So this is how a deep neural network looks like. So these deep neural networks completely learn the data which is fed to it. So this is the data. So let's say if this image of woman is fed as the data to the deep learning model, then it will completely extract all the features of this data by itself. Again, the difference between ML and deep learning over here is that the feature extraction in machine learning is manual. But when it comes to deep learning, the feature extraction is automatic. So the deep learning model automatically extracts all of the features associated with that image. And when new images are fed to it, it automatically is able to tell whether the image is same to this or not. So this over here we have a graph which tells us how does performance vary with respect to the amount of data. So what happens in machine learning is that as we keep on increasing the data, the performance increases only up to a particular threshold. After that, if we increase any more data, there is no increase in performance. So this is another problem when it comes to machine learning. But on the other hand, when it comes to deep learning, the more amount of data you give it, the better will be its performance. And that again is because deep learning is based on learning data interpretation. So the more data you give it, it will automatically learn all those features of the data by itself, and it will be keep on increasing its performance gradually. Now let's look at some applications of deep learning. So speech recognition is one application of deep learning. Now you need to understand that you cannot build speech recognition applications with machine learning. So this is where machine learning fails, and deep learning comes in and helps you to build speech recognition applications. Also, another application of deep learning is self-driving cars. So we see over here that the person is just sitting. He's not even touching the steering wheel and the car is driving by itself. So just an amazing application of deep learning. And then we have language translation over here. So this again is a part of deep learning. So over here we are typing something in Spanish and it is being automatically converted into English. So we also have visual translation over here. So over here this text or this board is in some random language, and this app over here which uses deep learning automatically converts this visual into English. So those were some applications of deep learning. Now let's actually understand how does deep learning work. So most deep learning methods use neural network architectures, and that is why deep learning models are often referred to as deep neural networks. So a deep neural network basically has these three models: an input layer, the hidden layers, and the output layer. And the term deep usually refers to the number of hidden layers in the neural network. So traditionally, neural networks only contain 2 to 3 hidden layers, while deep networks can have as many as 150 hidden layers. Now that's a very huge amount, isn't it? So deep learning models are trained by using large sets of labeled data and neural network architectures that learn features directly from the data without the need for manual feature extraction. So all of the input data is given to this input layer, and this input layer automatically extracts the features by itself. Now that data is sent to this hidden layer which performs all sorts of processing tasks, and then the final result is given out through the output layer. So now let's also understand what exactly is a neural network. So a neural network is a computing model whose layered structure resembles the network structure of neurons in the brain with layers of connected nodes. So it can learn from data which can be trained to recognize patterns, classify data, and forecast future events. So the neural network is based on the biological neural network of our brain. So that is why it is given the name neural network. So the layers are interconnected via nodes or neurons, with each layer using the output of the previous layer as its input. So its main function is to receive a set of inputs, perform calculations, and then use the output to solve the problem. Now, as I've already said, these artificial neural networks are based on something known as a biological neural network. So our biological neural network has dendrites, cell body, and axon. So dendrites are where the input is taken, cell body is where the processing is done, and axon is where the message is transferred to other neurons. And the same thing happens in artificial neural network as well. So first we give in the data, that data is processed, and then the final processed result is given out as the output. So over here, let's say we train the data with images of cat, and the labels would be either cat or not cat. After that, we give in a new image of a cat, and then we basically try to predict whether the model correctly classifies this as cat or not cat. And since the model has learned the data properly, it correctly classifies this image as cat. Now there are many ways of knitting the nodes of a neural network together, and each way results in a more or less complex behavior. Possibly the simplest of all topologies is the feed-forward network. So when feed-forward neural network, signals flow in one direction without any loop in the signal paths. And typically, artificial neural networks have a layered structure. The input layer picks up the input signals and passes them on to the next layer, known as the hidden layer. And there can be more than one hidden layer in a neural network. And at last comes the output layer that delivers the result. Now, the first question to pop into your head would be, what is the inspiration behind these artificial neural networks? Well, the answer to that is the biological neural network of our brain. So let us first understand the architecture of a biological neuron. So as you can see in the slide, our biological neuron has these three main components. So we have the dendrite, the cell body, and the axon. These dendrites receive the signals and the cell body processes these signals, and the axon finally sends out these signals to other neurons. So just like the biological neuron, the artificial neuron has a number of input channels, a processing stage, and one output that can fan out to multiple other artificial neurons. So now let's understand these artificial neurons in detail. These artificial neurons are the most fundamental units of deep neural network. It takes an input, processes it, passes it through an activation function, and returns the output if the condition is met. Or else it will process it again until you get the correct output. And such type of artificial neurons is called as a perceptron. So they are basically like a linear model which is used for binary classification. So as the figure shows, we have x1, x2, x3 and going on till xn as inputs in the input layer. Now, to which we add the weights and the bias that are randomly selected. So here we have w1, w2, w3 going on till wn as weights. So we multiply these weights with the corresponding inputs and add all the values together, and finally we add bias to that sum. So this final sum is passed through an activation function which finally gives us the output. So let us see this in detail. So here we have three arrows which correspond to the three inputs coming into the network. Now for these three inputs, we have corresponding weights associated with them. So input 1 is associated with a weight of 0.7, input 2 is associated with a weight of 0.6, and input 3 is associated with a weight of 1.4. Now, these inputs are multiplied with their respective weights and their sum is taken. So if the three inputs are x1, x2 and x3, the sum would be x1 into 0.7 plus x2 into 0.6 plus x3 into 1.4. And to the sum, we add an offset which is called as bias. So this bias is just a constant which is used for scaling purpose. Now let us understand the concept behind these weights. So these weights basically determine the relative importance of the inputs. So let's say we have two inputs, humidity and wearing a blue shirt. So here we can see that wearing a blue shirt has almost no correlation with the possibility of rainfall. So that is why the weight assigned to input x2 would be low in order to bring down its importance. Now let us see why do we need activation functions. So consider this scenario where you have two different classes. One class is represented with triangles and the other class is represented with circles. Now let's say I ask you guys to draw a linear decision boundary which can separate these two classes. So is that really possible? Can we draw a linear line which can segregate these two classes? Well, the answer is obviously no, isn't it? So let me tell you guys how can we do this. So we'll have to add a third dimension to create a linearly separable model which is easy to deal with. So the logic is, when you're going from 2D to 3D, you're making your equation non-linear. So with the third dimension, I have introduced non-linearity in our data, which helps in creating a linearly separable model. And in real-world situations, you don't always get linear problems. So you should know how to deal with non-linear problems as well. And this is where activation functions help us to convert the linear equation to non-linear form. So these activation functions bring in non-linear functional mappings between the input and the response variable. Their main purpose is to convert an input signal of a node in an artificial neural network to an output signal. And if we do not apply an activation function, then the output signal would just be a simple linear function. Now there are many types of activation functions, and today we'll be discussing some of the widely used ones. So let's start with the identity function. So the identity function gives out the same output as the input. So no matter how many layers we have, if all the activations are identity functions, then the final output of the last layer would be the same as the input given to the first layer. And the range of the identity function goes from minus infinity to plus infinity. So after that, we have the binary step function. So this binary step function is usually denoted by h or theta, and it is a discontinuous function. So if the input is less than 0, then the output would be 0. And if the input is equal to or greater than 0, then the output would be 1. And this is why binary step function is used to solve a binary classification problem. So after that, we have the sigmoid function. So the formula for the sigmoid function is denoted by 1 upon 1 plus e power minus x. The sigmoid function basically scales the values between 0 and 1. So if the input is a large negative number, it is scaled towards 0. And similarly, if the input is a large positive number, it is scaled towards 1. Then we have the tan h function. It is a hyperbolic trigonometric function which scales the values between minus 1 and 1. So one advantage of tan h function over sigmoid is that it can deal more easily with negative numbers. And after that, we have the ReLU function, which stands for rectified linear unit. So this function will give out 0 if input is less than 0. And on the other hand, if input is equal to or greater than 0, then it will act as an identity function and give out the same value as the input. And this ReLU function is the most widely used activation function and is primarily implemented on the hidden layers of the neural network. Then we have the leaky ReLU, which is just a modified version of ReLU. So the leaky ReLU, instead of just completely removing the negative part, it just lowers the magnitude. And finally, we have the softmax function, which is ideally used in the output layer for classification problems. So the softmax function basically gives a set of probability values for each class of the output. And that particular class, which would have the maximum probability, will be our output class. So that was all about activation functions. Now let us learn more about perceptrons. So like we were taught how to behave in certain conditions, perceptrons also require training. So they have a learning algorithm through which they produce the output. By training a perceptron, we try to find a line, plane, or some hyperplane which can accurately separate these two classes by adjusting the weights and biases. So consider this image where we give the dogs and horses as input. So here, after the first iteration, error value is 2 since the horse has been classified as dog and there is one dog which is placed in the horses class. And in the second iteration, the error value is reduced to 1 as it is just the dog which is classified as a horse. And finally, in the third iteration, we get the correct output as the perceptron has been trained well with no error. So all the dogs have been placed in one class and all the horses have been placed in one class. Now let's understand the perceptron training algorithm. So this perceptron over here receives multiple inputs and each input is initialized with a random weight. So after these, we multiply these weights with their corresponding inputs and then we get the sum. Now this input is passed through the activation function, which would give us a non-linear output. So this process until here is known as feed forwarding. Now, if the output which we get is not optimum, we calculate the error in prediction and then go back and then update the weights and bias. So this process where we go from output to the input layer is known as backpropagation. And we keep on backpropagating until we get the desired output. So that was the perceptron training algorithm. Now let's have a look at the benefits of using artificial neural networks. So the artificial neural networks can learn organically. This means an artificial neural network's outputs aren't limited entirely by inputs and results given to them initially by an expert system. So artificial neural networks have the ability to generalize their inputs. This ability is valuable for robotics and pattern recognition systems. Artificial neural networks also help in nonlinear data processing. So nonlinear systems have the capability of finding shortcuts to reach computationally expensive solutions. These systems can also infer connections between data points rather than waiting for records in a data source to be explicitly linked. This nonlinear shortcut mechanism is fed into artificial neural networking, which makes it valuable in commercial big data analysis. Artificial neural networks also have high potential for fault tolerance. When these networks are scaled across multiple machines and multiple servers, they are able to route around missing data or servers and nodes that can't communicate. And these artificial neural networks can also self-repair themselves. So if they're asked to find out specific data that is no longer communicating, these artificial neural networks can regenerate large amounts of data by inference and help in determining the node that is not working. This trait is useful for networks that require informing their users about the current state of the network and effectively results in a self-debugging and diagnosing network.
Just a quick info, guys. Intellipaat provides NLP training using Python mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
So when you hear the term TensorFlow, the first question to pop into your head would be, what exactly is a tensor? So in TensorFlow, data is represented in the form of tensors. Simply put, a tensor is a multi-dimensional array in which data is stored. So you can consider these tensors to be the building blocks in TensorFlow. Now, these very tensors are given as the input to the neural network. So as I've said, a tensor is nothing but an n-dimensional array. So the number of dimensions used to represent the data is known as its rank. So if a tensor has just one element, in other words, if it has just magnitude and no direction, then its rank will be 0. If a tensor has magnitude and direction in one plane, then its rank will be 1. Similarly, if a tensor has magnitude and direction in two planes, then its rank will be 2. And this goes on higher up the order. Now, TensorFlow, as the name states, is a combination of two words, tensor and flow. Here, the data is stored in tensors, but the execution is done in the form of a graph. So this is not like your traditional programming where you just write a bunch of lines and everything gets executed in sequence. So first, you'd have to prepare this computational graph, and then this computational graph is executed inside something known as a session. Now, in this computational graph, all the mathematical operations are depicted inside the nodes, and all the tensors are represented on the edges. So the entire computation process is done in two stages. In the first step, the code is depicted onto the computational graph, and in the second step, a new session environment is started and the graph is executed inside this session. So that was all about the computational graph. Now let's look at the program elements in TensorFlow. So we have three program elements: constant, placeholder, and variable. So let's start with constants. So constants are program elements whose value does not change, or in other words, the value is fixed. So let's head on to Jupyter Notebook and work with these constants. Right, so my first task would be to import the TensorFlow framework. So I'll type import TensorFlow as TF. I'll click run. So let me just wait till the import is done. Right, so we have successfully imported the TensorFlow framework. Now, as I've said, let's go ahead and start working with the constants. So let me just type in constants over here. So I'll create the first constant and name this constant as con1. Now this is how we can create constants in TensorFlow. So I will use this TF and then put in a dot and then type in constant. Now inside this I will give the value of the constant. So let's say the value is 10. So this is an integer type constant. Now similarly I'll also create a floating type constant and I'll store this in con2. So I'll type TF dot constant. And the floating value would be 3.14. Now after this I'll create a string type constant. So again this would be tf dot constant, and the string which I'd be giving would be this is Spara. And finally, we have a Boolean type constant, and I'll store this in con4. So this will be tf dot constant, and let's say the value is false. Now I'll run. Now let me print all of these values. So I'll use the print function, and then I'll go ahead and print all of these values, con3, con4. Right. So we see that this first constant is a tensor of type integer. This second constant is a tensor of type float. This third constant is a tensor of type string, and this fourth constant is a tensor of type boolean. Now we see that we only have the data types of all of these tensors, but we don't have their values. This is because, as I've already told you guys, we have to create a computational graph and then execute that computational graph inside a session. But till now, we have not started our session. So let's go ahead and start a session first. So I'll type ses equals tf dot session, and I'll hit run. Now I will run all of these inside this session. So I will type ses dot run, and let me go ahead and run all of these: con1, con2, con3, and con4. So this time we have the values of all of these tensors. So the value of constant 1 is 10, the value of constant 2 is 3.14, the value of constant 3 is this is Sparta, and finally the value of constant 4 is false, right? So first we'd have to create all of the constants, then we'd have to create a session, and inside this session we'd have to run all of these constants. Now let me go ahead and perform some simple operations on all of these constants. So let me just type in operations over here. So I'll do a simple addition operation. So I'll type addition over here. And let's say the value of the first constant is 20. I'll put a plus symbol, and then I'll take in the next constant, and the value of the second constant would be 30. So I am basically adding two TensorFlow constants. The value of the first constant is 20, the value of the second constant is 30, and I'm storing that result in addition. Similarly, I will multiply these two constants now. So multiplication tf dot constant. So I'll give the value of 20. Now I'll put the asterisk symbol, and then this would be tf dot constant of 30. So this time I'm multiplying these two values, right? So I'll hit on run. So now again, if I'd have to see the resultant addition and multiplication values, I'd have to run these two inside a session.
Just a quick info, guys. Test your knowledge of NLP by answering this question. To which of the following fields does NLP belongs to? A. Computer science. B. Artificial intelligence. C. Linguistics. D. All of the mentioned above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So I'll type ses dot run, and then put in these two values over here, addition and multiplication, right? So we see that 20 plus 30 gives us an addition value of 50. And similarly, when we multiply 20 with 30, we get a result of 600, right? Now, so this was basic operation with scalars. And we already know that tensors can have higher dimensions. So let's go ahead and perform addition and multiplication with these higher dimension tensors, right? So again, I'll just put in addition over here, and I will take in the first constant, and inside this, I will give in a list of values. So let's say I will take in 1, 2, 3, 4, and 5. And I will add this list with the next constant. And this time, the second constant has the values of 5, 4, 3, 2, and 1. Similarly, I'll also multiply. So multiplication equals tf dot constant. And this will have values, let's say the same values, 1, 2, 3, 4, and 5. Let me put a comma over here. Right. Now I'll put the asterisk symbol, Again, I'll type tf dot constant and I will give in the list of the values 5, 4, 3, 2 and 1. Now I'll hit run. Again, I need to run these two inside a session. So sys dot run. Let me put in addition over here. After that, I would also need the multiplication value. Right, so this is a result. So when we add 1 plus 5, we get 6. When we add 2 plus 4, we get 6. Similarly, when we add each of the corresponding elements with these elements inside the list, we get all of the 6's over here. Now let's take this multiplication result. So over here, when we multiply 1 with 5, we get 5. When we multiply 2 with 4, we get 8. 3 cross 3 gives us 9. 4 cross 2 gives us 8. And again, 5 cross 1 gives us a 5. So this was addition and multiplication with respect to lists. Now let me also do a simple operation on strings. So let me take in the first string and name it as str1. So this is a constant. So tf dot constant. And let's say and again this would be a constant. So tf dot constant. And the value of this constant would be Tensorflow. Right. Now I will run this and let me execute this inside a session. So sys dot run of str1 plus str2. So the result which you get is I love Tensorflow, right? So the first string is I love and then there's a space and the second string is Tensorflow. So when I add these two strings, the resultant is I love Tensorflow. Right, so that was all about constants. And then we have placeholders. So when it comes to placeholders, we don't have to provide an initial value and can specify it during the runtime. So this allows us to build our computational graph without needing the data. And this is how we can create placeholders. So tf.placeholder is the syntax. And inside that, we just give the data type of the variable, which we will substitute later on during execution. So let's head back to Jupyter and work with these placeholders. So let me just type in placeholder over here. So let me create my first placeholder. So I'll name that as A and tf dot placeholder, and this would be of integer type. So tf dot int 32. Now I will create another variable which would be b, and the value of b would be actually a cross 2. So let me run this. Now I will run these two inside a session. So sys dot run, and I want to see the result of b. So I'll put in b over here. Now, since we know that a placeholder takes in a value during runtime, so this is when I'll feed the value to this placeholder a over here. Now to do that, I would have to create something known as a feed dictionary. So feed dict equals, let me create a dictionary over here. So it would be a, and the value which I'll be giving to a would be, let's say, 5. Now let me run this and let's see what do we get. Right. So during the execution time, I have assigned a value of 5 to a. And when we multiply this 5 with 2 over here, we get the value of b, which is 10. Right. So all of this is happening during runtime because with the help of a placeholder, we can assign it a value during execution. Now, similarly, let me go ahead and give a list of values over here. So instead of 5, let me give the list of values 1, 2, 3, 4, and 5. Now I'll run this. So over here, 1 cross 2 gives us 2, 2 cross 2 gives us 4, 3 cross 2 is 6, 4 cross 2 is 8, and 5 cross 2 is 10. So you get an array of values during runtime. Now, similarly, let me also create a placeholder for strings. So I'll type string placeholder over here. So now let me create this variable and name this as string name. And this would be a placeholder. So tf dot placeholder, and I am taking in a string. So tf dot string. Right. Now let me create another string over here. So the name of this string would be my name.
And let's say the value of the string is I am. Alright. Now let me run this and I'll execute this inside a session. Sys dot run, and I want the result of my name when I add it with respect to string name. Now let me also create a placeholder for strings. So I'll just type string placeholder and let me create the first placeholder. So I'll name that as str1 name, and since this is a placeholder, tf dot placeholder, and I will be giving in a string during execution time. Now I'll also create another string value over here and name that to be my name, and the value of this string is I am, and then I'll give a space. Right, so now I'll hit run and let me execute this inside a session. Now let me also create a placeholder for strings. So this will be string placeholder. Right, so let me create this placeholder. I'll name this as str name, and since this is a placeholder, I need to use tf.placeholder, and I will be assigning a string to this during execution time. Now I will also create another string which would be my name, and this would be equal to I am, and there's a space, and I will be adding this with str name. So let me hit run. Right, now I'll execute this inside a session. So for that, I'll type sys dot run, and I want the result of my name. So I'll just put in my name over here, and then I'll provide the feed dictionary. Feed dict equal to, let me put in the dictionary over here, and I will assign the values of str name over here. Right. So the values of str name would be Sam, Bob, and Charlie. Now let me hit run and let's see what do we get. Right. So what we are basically doing is we are adding this with the placeholder value over here, and we are giving the values during the execution time. So I am Sam, I am Bob, and I am Charlie. Now these three values are coming from this feed dictionary during the runtime. Right. So this is all about placeholders. And finally, we have variables. So a variable is just a program element which allows us to add new trainable parameters to the graph. And this is the syntax to create a variable. tf.variable, and then we give the value, or we initialize the value, and then we specify the data type of that variable. Right, so let's head back to Jupyter now. I'll just type in variables over here. Right, so let me create my first variable, and the name of that variable would be var1, and we can create a variable like this, tf.variable. So guys, you need to keep in mind that this V over here is actually capital. Right. So now after this, I would have to assign a value to it. So let's say I assign this variable a value of 20. And this is of integer type. So tf.int32. I'll run this. Now another thing to be kept in mind is whenever we are declaring values in TensorFlow, they have to be initialized. So this is how we can initialize all of the variables. So we have something known as global variable initializer. And when we invoke this function, all of the variables which we have declared would be initialized. I'll hit run. So now let me execute this inside a session. So sys.run of init, and I have initialized this variable over here. Now let me also go ahead and run that variable, sys.run var1. Right, so we have the result of var1, which is 20. Now since this is a variable, the value of a variable can be actually updated. So let me go ahead and update the value of this. So I will name this as updated var1, and the function would be tf.assign.
And inside this, the first parameter would be the variable which I'd want to update. And after that, I need to give the value to which I'd want to update this. So I want to make this value of 20 to 25. Right, now I will run this. So now this is actually a variable. We can actually update the values. So let me go ahead and do that. So the name of the updated variable would be, let's say, updated var1, and the function for that would be tf.assign. And this takes in two parameters. The first parameter would be the variable which we are supposed to update, and the second parameter would be the value to which we are updating it. So I want to make this 20 to 25. I'll hit run right now. Let me run this inside a session. Sys.run, and I need to pass in the variable which would be updated var1. Let me make it small v over here. I'll run this. Right. So initially the value of var1 was 20, but we have updated it and made its value to be 25. Now let's also go ahead and create a small linear model. So let me just type in linear model over here, and this is how our linear model would look like. Wx plus b, where w and b would be variables and x would be a placeholder. Right, so let me start off by creating w. So w is a variable, so w would be equal to tf dot variable, and I am initializing it with a value of, let's say, 10, and this is of integer type. So this would be tf.int32. Now, similarly, I will also assign the value for b. So b is also a variable and its initial value would be 5, and this is also of integer type. And finally, we have x, which is a placeholder. So x is equal to tf.placeholder. And since placeholder does not actually take an initial value, it just takes a data type. So the data type is again tf.int32. So I'll run this, and now what I'll do is I will multiply w with x and add b to it. So the equation would be w cross x plus b, and I will store it in a variable and name that variable to be linear model. Right, so this is w cross x plus b. I'll run this. Now again, if I have to execute this, I have to run this inside a session. And since also I have created two new variables, I'd have to initialize them first. So init1 equals tf dot global variables initializer. I'll hit run. So now I will create a session. So sys.run, and I will execute init1 first. So I have successfully initialized these two variables w and x. Now I can go ahead and run this linear model. Sys.run. Now I would want the result of linear model. So linear model, and then I will use the feed dictionary. Now inside this feed dictionary, I would have to assign a value to this placeholder x. So x equal to, let's say I give a list of values over here, and the list of values would be 1, 2, 3, 4, and 5. Now I'll run this, and let's see what do we get. Right. So if the value of x is 1, we get 15. So this basically means that 10 into 1 plus 5, which is 15. Now after that, if the value of x is 2, so this would mean 10 into 2 plus 5, which is 25. Similarly, if x is 3, that would mean 10 into 3, which is 30, plus 5 is 35, right? And same is the case for 4 and 5.
This brings us to artificial intelligence developers. Who are these guys and what do they do? Well, you need to know this. Again, AI developers are basically computer science based people, and these people have to do a lot with coding. Programming languages such as Python, languages such as R, and many other programming concepts. So why do they need all this programming? Well, this is basically to ensure that they can design, maintain, test, evaluate all the artificial intelligence solutions that certain organizations need. So let's say again, the AI technology which is gone into building Siri at Apple might be extremely different, is definitely very different than the technology which went into Tesla's autopilot, right? So these developers need to understand what the problem is, make sure they can formulate the problem and then formulate a solution for that problem as well, right? So designing a solution for an artificial intelligence requirement, and in fact maintaining that product after it's been designed and evaluating to make sure that it is performing right where it should, is again very important aspects of an artificial intelligence developer. And I have a quick question for you guys on that note. So I'm pretty sure most of you guys use social media, right? It might be Facebook, it might be Instagram, it might be Twitter, and it might be all the other fancy social media apps out there. Coming to Facebook, let's see how AI developers pretty much work out here, right? So AI developers are pretty much responsible again to handle about 350 million photos a day which has been uploaded to Facebook, and they do a lot with face detection and image recognition as well. So let's say you and your friends decided to go on a vacation. Let's say there were 10 people of you and you clicked about 300 pictures. Now imagine tagging 10 of these people in all the 60 pictures, right? So again, 600 tags you have to do manually, and this is going to take many hours if you have to do this. But then Facebook already would understand who the person that is in the picture, where the picture was clicked, and much more. That is what geotagging means, and location options too. So this is told to you very subtle. It says, hey, was the picture clicked here? Is this person that? I mean, it'll show you the name of the person and it'll show you the location as well, and you might be like, yes. So at that point of time, you might not recognize and realize the power that's working behind it to get you all the details, right? Again, and another important thing is automatic friend suggestions, right? So let's say you added someone on any of their other applications. Now Facebook owns WhatsApp and Instagram. So let's say you're in touch with someone on WhatsApp where you've saved their number or something. Facebook will tell you, it'll give you a friend recommendation saying, hey, why don't you add that person on Facebook as well? So imagine all the processing that goes behind this particular thing. I mean, it's so subtle, as I mentioned on the first slide, that we don't even know it's there anymore. And then when you talk about Instagram, see, there are 95 million photos which get uploaded to Instagram, and handling that is definitely a task, right? And the best thing that Instagram is known for these days is customized advertisement. So you go to Amazon, you're searching for the latest mobile phone, or you're searching for a mobile cover, tempered glass, whatever it is. As soon as you come back to Instagram, it's going to show you one advertisement which is beautifully put together. You'll feel like clicking on the advertisement. Basically, that's how customized these advertisements are. And again, face detection and object recognition as well. So that plays a very important role in Instagram. Location recommendation systems, again, it will just tell you where the photo was clicked, what time the photo was clicked, and much more. Friend recommendation again. So let's say again you added someone on Facebook, or you guys just let's say there are two people who use Instagram. You guys have talked on another social media, but then you guys decided to meet for breakfast or dinner or whatever. And as soon as you come back to Instagram, it's going to give you a friend recommendation saying, why don't you add this person on Instagram? Again, how does this work? Artificial intelligence is at play, my dear viewers. And then coming to Twitter handles pretty much 6,000 tweets per second. Again, there has to be some form of pretty much a pipeline, a channel for the data to flow through in and out of the Twitter's storage area, where pretty much they need to understand, they need to work with this data, because it's not all about storing the data when it comes to Twitter, right? Because they perform sentiment analysis of every single tweet. They check if the tweet has a positive sentiment, a neutral sentiment, a negative sentiment, and what pretty much they can check to the depths of what person in which area liked or disliked this tweet on the face of the globe, basically. So this will add power to their organization. This will make sure that marketing can be done using Twitter, and in fact at the end of the day you're bringing more sessions to Twitter and they're happy. Coming to outreach analytics and customized marketing, again pretty much it'll tell you who your audience is, when they're watching your tweets, when they're reading it, and why as well, right? So coming to data analytics, again you can pull out any number of statistics you want with respect to sentiment analysis of any tweet that's present on Twitter, guys. So think about it. We never knew a simple tweet can have this much of a complex circumstance in the back end when we talk about data and artificial intelligence, right? So this brings us to the most important aspect of this video, guys, which is the skills needed to become an AI developer. And let me tell you about 3 important skills that I think you should have. And the first one is all about mathematics and all about algorithms, guys, because at the end of the day, you need to understand how numbers can in fact be used to achieve artificial intelligence. There is so much that you might not know, and to the intermediate level viewers, pretty much you will know how much of importance mathematics and statistics play a role. And then coming to algorithms, all the machine learning algorithms are again one step closer to making the machines intelligent. All concepts such as machine learning, deep learning, neural networks, all these are work under the same umbrella of artificial intelligence. All of these terms that I told you, all of their goals is to achieve artificial intelligence at the end of the day. So having very good mathematical skills and being well versed with the top algorithms which works with, again, based on statistics, is very vital. And second of the 3 most important skills is probability and statistics, guys. Why did I mention statistics again? Well, it is that important. You need to understand all the concepts, everything from the basics of correlation, all the way till how you can basically churn through data and make sure the data will give you insights that the naked eye might not tell you at all. So that is one of the reasons why statistics is extremely important. Coming to the world of probability, again, we need to sometimes understand that the values can be continuous, the values can be discrete. We need to find out what a possibility of occurrence of something is, right? So that, again, pretty much an artificial intelligence algorithm of today will not give you 100% accuracy all the time. It will give you an accuracy of 80, 90, 95, 98%. Again, this 98% is 9 on 10 probability. So it says that there are chances that it might fail 2 times out of 100 times. Again, probability, right? So this is a very important second skill to have. Coming to the third most important skill is having the knowledge of a programming language, guys, because again, there are languages like Python and R which form a very strong requirement when you have to learn about artificial intelligence and to help you become an AI developer. And you can either go on to learn Python, you can go on to learn R, but then beginners do prefer Python because R actually has a steep learning curve which some of the beginners might find difficult. But then do not worry, you can pick up either Python or R and you can be on your way to become an AI developer. And then coming to what R is majorly used for, well, R is actually used to do a lot of data plotting, a lot of statistics, and it involves a lot of bringing mathematics and programming together, is what I want to tell you guys. And then Inagist, again, most of the companies which basically has open positions for AI developers has these roles always present. So you need R and or Python, you're going to need statistics, you're going to need to work with algorithms, machine learning, and so much more. And on that note, here is a step-by-step guide on how you can become an artificial intelligence developer. Let us begin with step 1. Step 1 is pretty much, again, you understanding data structures in detail. You might be wondering why you need data structures, right? Again, if you understand how your data is stored, how your data is talking to the other entity that is present next to it, then you will understand how you can increase the performance of an algorithm by making it improve itself by drastically changing its understanding of its neighboring data. So understanding the right data structure, understanding when to use what data structure is extremely important. And this is step number 1. Guys, I urge you guys to pretty much whip out your pen and paper or make notes of these, as this will help you a lot in case if you guys are considering to becoming an AI developer. Coming to step number 2, again, as I mentioned, programming. So Python and R are the biggest names when it comes to a programming language to help achieve artificial intelligence. And programming knowledge is vital, guys. It is necessary. There is no work around this, and in fact, it is so much fun to work with, and I've been working on this for a couple of years and I absolutely love it. So, working on Python, working in R, there are libraries for machine learning, there is Tensorflow, there's scikit-learn, there's PyTorch for neural networks, there's CNTK, that's the Microsoft's cognitive toolkit, and there are much more. There is Staffy, pretty much, guys. If I have to go on to naming the frameworks, I can keep on going. So when you think about this, there are so many things out there that you need to know and this already forms the step number 2. So what comes after this? Well, step 3 is understanding a little bit of mathematics, guys. You need to have some sort of clarity on how numbers can actually be used to drive a data driven entity into making it self-sustain, because at the end of the day, statistics will play an extremely vital role in making sure your machine understands what's going on in it and derive some sort of continuous or differential inferences based on that. And then this brings us to step number 4. Step number 4 is the most important part, ladies and gentlemen, because here again you will be finding a problem. This is how you have to go by with step number 4. Find a problem which needs a solution. Let's say it might be a new startup that your friend is starting, or you just spotted a common problem across your daily life. So find that problem and make sure that you can formulate the problem and understand what the actual problem is. Now find a solution to that problem, and after you found a solution to that problem in a general human way, try to see if you can get the machine to do it. If you can implement artificial intelligence to do it almost as good as you, if not better, then your job is done. But then you need to understand that at the end of it, you becoming an artificial intelligence developer. So telling the world about it is again very important as well. So there is this website called as Kaggle, where pretty much it's an amazing community where people pretty much come together, give out their problems, give out solutions. There are challenges that you can take place in, and basically it's like a GitHub for programmers. Again, GitHub is the same thing, but when we talk about it, Kaggle is a little different, and I'm sure you guys will know how when you go on to explore Kaggle, which is your step number 4. So coming to step number 5. Step number 5 involves you to understand a little bit of cloud computing, because again, in today's world, half of the organizations we see around us are already scaled to the clouds. So everything from Amazon Web Services, we have GCP, which is Google Cloud Platform, we have Microsoft Azure, and much more. So taking artificial intelligence and scaling it right up in the sky through the clouds is now booming. And as my dear viewers, I have to tell you that having a good certification which will train you on all of these concepts is extremely vital. Working on AWS, working on GCP or Azure or any of these, so having cloud computing knowledge and bringing it together with artificial intelligence are very vital. And coming to step number 6. Step number 6 is again an important aspect for an AI developer, because not only you'll have to work with one single computer at point of time, you'll have to work with multiple entities, multiple computers, because at the end of the day, you're going to use this to exponentially increase your computing power. And this is basically done to understand how you can gain some sort of systematic knowledge onto scaling this artificial intelligence entity that you're developing onto a modern infrastructure. This is very vital, guys. So to revisit all the steps, here's a recap. Your step 1 will begin by understanding data structures. Step 2 with a programming language and some libraries. Step 3 is mathematics and statistics. Step 4 is finding a problem, analyzing it, and solving it. Again, the next step involves scaling artificial intelligence to the clouds, and the last step is to understand how you can make use of artificial intelligence on multiple machines at the same time, which is basically distributed computing. And to basically strengthen everything that I've said, here are some of the sample job descriptions that we can check out. So here's a job description for an artificial intelligence developer from the Penn State University in the United States of America. Their requirement is this. They say proficiency in Python is needed, experience with machine learning library Tensorflow, Infinite Cafe is needed, and pretty much they say proficiency in mathematics is needed, as we discussed, linear algebra, multivariate calculus, and much more. Skill is required in JavaScript or R, as we discussed, data structures, and ability to communicate technical topics to the people who might be non-technical audiences. And then cloud computing, AWS, as I told you, right? So we discussed all the 6-7 points, and again, you can see just in one job description, we can see all those 6 points reflecting onto us, right? And then in fact, coming to a researcher's jobs, we just checked out the artificial intelligence developer role. Let's check out the artificial intelligence researcher's role. Again, this comes from the Massachusetts Institute of Technology. It's called Lincoln Laboratory. These guys as well, they require you to have experience in machine learning software, PyTorch, TensorFlow, MixNet, Scikit-learn, and much more. They would appreciate if you guys had experiences in working with large computer vision data sets, experience with big data, Hadoop, Spark, Elasticsearch, Cassandra. You'll be able to work in a multidisciplinary team environment. You have to have very good communication skills, oral skills, and sometimes you might have to travel as well. So guys, when we think about these two job descriptions of an AI developer and an AI researcher, again, when you you come to think about it, we have validated all the points that we pretty much just discussed, right? And this brings us to the most important part of our live session, which is pretty much to tell you what the average salary is. So here is the average salary, guys. So pretty much again, when you think about it, the average salary of a junior AI developer is somewhere around $80,000 in the USA, 7 lakhs per annum in India, 45,000 pounds in the UK, and then a senior AI developer has up somewhere around $115,000 in the US, 15 lakhs per annum in India, and 60,000 pounds in the UK, guys. So these are some of the very big numbers that you can see when we talk about AI developers, AI researchers, and then as I told you, this is a very lucrative career that you can pretty much jump onto, guys.
Just a quick info, guys. Test your knowledge of NLP by answering this question. Which of the following includes major tasks of NLP? A. Automatic summarization. B. Discourse analysis. C. Machine translation. D. All the mentioned above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session. Just a quick info, guys. Intellipaat provides NLP training using Python mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
Okay, let us understand what is the use case going through and why we are doing this. So why this house price prediction is needed in current scenario. Even we can know that, okay, in India, like in Bangalore, the house prices are much more. In Kolkata's a little bit less. In Delhi, little bit more. In Mumbai, costly. Chennai, somehow reasonable price are there. So my question is that if the user giving a wrong input or very random input, how can the model manage that? So that, because the success of the model is not when user is giving the correct data. The success of the model is there when the model can identify the user is not giving the right data. Like for example, when I am booking Ola and give a location that is out of my city, that is the drop location, which is basically not come under the range of the Ola services. So Ola service give me, means Ola, the application directly give me a pop-up that it is out of our service, please select a location properly. So my question is that how can we or how can this model, or how can we build this house prediction model so that whenever the user gives the data, the model itself give the probable output as well as the probable wrong inputs. If that is the case, then how the Google card is working? Because if you means order, or if you give a command to the Google card that, hey, go to this road and you will reach to my destination without going left or right, just follow this road as a straight away. But the Google card will not do that. He repeatedly warned you and then take the decision that, hey, there is no straightaway road to your destination. We need to go to the go to this, or we need to follow this route. The Google recommendation, the house price prediction, it's also a recommendation. So that's why my idea means my opinion, or you can say I am trying to let you all understand that what is the main basic point we need to think of whenever we go through this type of assignments, because these are very simple basic assignments, but in our companies, when we will work on that, then we need to think of the business problem, that what business problem we should solve and how should we solve, right? So house price prediction itself a recommendation problem where the machine gives the recommendation to the user that, hey, these are the prices as per your input. So now coming to the point that why I am saying this. See, when I go through this project first, I thought, hey, this project is a very simple project. Why means what the hell Kaggle is giving this type of projects? What is the reason? Anyone can do that. Anyone can build a model. What is the difference? So Kaggle is doing this because they're trying to understand that how anyone can think out of the box and give a model which can not only give the output but also can give the correct output based on the wrong input. So how can anyone can understand, or how the model can understand that this is the wrong model or wrong input? Let me explain the thing. Now coming to the point, let's give an example. In this screen, when I selected the ID, let's take this ID as the people ID. Okay, let me first data set. So I feel you already have the data set. Data is taken from different users. It might happen some users give a very good result, means very good input. Some users don't give a very good input, so that there is a biasness. So we need to think of in different way that how can we manage this type of biasness. That's not a very big deal. We can identify in a different way. But let's assume that whatever in the trained data set is, every data is a very good data and very specific data. Right way people input their all informations to this thing, which is a good thing. Let's assume that. Okay, now there is a new set of test data. So now you need to understand the basic direction, that where and how we will work on. So can anyone give me a very simple one-liner idea that what is the relation between train and test dataset? There is a very simple relation between train and test dataset, assuming that there is no bias. The dataset is basically unbiased dataset, and with least variance. Let's assume this. Assuming this, can anyone give me the one-liner statement that what is the relation between train and test dataset? Between train and test data, it's a means need actually. It's a need because we need that to take the model trained and work on the test data. So it's a need, it's not a relation. So do any one of you think before this session, or think before while entering in the data science, that why we are taking data, train and test data? What is the basic relation between train and test data? Do anyone think or search in Google? Okay, everything is done on the data after split on the train test data as the untouched model. And let me say that why I am pressurizing that speak up, people, speak up, because I need that from your brain it's come out. Because once you say this, then it will be there in your mind for a long term, because this is the basic thing you need to understand. Then we are as data scientist is not our goal. Our goal is to learn like a data scientist. Then we can achieve the data scientist as usual. Okay, so now I am going to the why I am saying this and what is the relation between train and tests. What is the behavioral aspect of data sets? Anyone? Sailia, Sudha, Shruti Ranjan, Sankar, Ratul. So the relation between train and test data set is the behavioral relation. And why it is a behavioral? because we are training the model on the trained data sets on the basis of behavior. The inputs are basically just I'm showing you one thing. If you go with this whole data, I'm coloring in a different way. Okay, so till this, all the variables, whatever people are giving the input, these are the behavioral input by the user. Think about when we are giving any feedback to Ola or somewhere else, or like KFC or like Zomato or like Big Bazaar or like any retail shop, all those informations are basically the replies from our inner heart. That is our feeling. That is our behaviors. So this behavioral which is coming from our brain is the input to this model. So model is basically learning what our brain is thinking. Model is learning our brain, then model can identify whatever our brain can think of. And that's why the behavioral aspect level relation is much important between the train and test data set. Because if there is no relation between train and test data set based on the behavioral aspect, then model even failed. And that's why there are too many models failed, because of the simple reason. It's not like that model is not working. It's like that we are not giving the right input to the model. Like for example, for a baby, if I am tell the baby that hey, this is the aeroplane by marking a aeroplane, but I am marking a car and tell him hey, this is not the car, this is the train. So the baby will learn that as a train, and then after that it will give the output when I ask hey, what is this thing actually? He said about the train, it's not a car.
Yes, Abhi, your statement is absolutely fine, but the idea is that how do you distinguish the trained data set and test data set based on the behavior? Whether the behavioral aspect is there in the test data set and it is present in the trained data set, but not in the test data set. How you distinguish those things, or how you divide the data? How you divide the data in the whole data set?
Right.
You told that in the test data. Yeah.
I am coming to that point as well, Ranjan. I am slowly but steadily I am coming to that point. But let people understand that this is the behavioral relation. Now, your question is very good, that how can we distinguish that and how can we cluster or segment that? Very good question. That what is the variations? First, we need to understand what is the variations between the trained data and the test data based on the multiple model you can take off for this for identifying the variance. Like you can do some clustering techniques, you can do some segmentations, even you can do some k-means clustering, or like this way you can use any type of clustering technique to just understand, or you can even go with the scatter plot to understand that hey, what is the dots are telling about between train and test data and how it is behaving. So we need to understand the bias and unbiasedness as well as the difference of variance between train and test data. First we need to think of that. First we need to identify that. So it's a very simple thing I need to show you all. Here you can see that I take a random number, random customer. And here I can see that hey, between these two customers, these values are basically vary. These are very similar. These are variant like this way, so and so forth. I take a very random thing, very random value. So if my model, okay, let's take one more idea that. So here you can see that out of this simple two data, there is a false statement is 53% and true statement is 47%. Like this way, but it's a very minimum difference. Very minimum means it's almost 50-50. It can be so model can train on this type of data sets because it's a very means a very biased data set, and it's and when I'm saying about biased, it's mean the behavior differences are much less. That's why there is a very common thing, and that's why false statements are 53 only and true are 47. That's mean almost 50-50. So it can be done. But what happened if for your understanding, I am writing this false and true. What happened if for false it is 80% and it is 20%. So do you guys not think that if this type of data will come, this is a very unbiased and highly varied? There is a is much more variance between two type of data set, and if that is the case, then it will a very challenge. How we can do that? So first of all, we need to check about the segmentation or clustering technique using clustering, and as well as first we need to check about the clustering first. Second, we need to identify the correlations between all the parameters. For this correlation, you can check with the heat map or something like things which can be done. It's not a big deal for anyone. Everyone know that. So you can use covariance, you can use clustering technique to identify this. This is the main two thing. After that, when you are already satisfied that hey, this data set is unbiased, this data set is biased, and the correlations out of these correlations, these are the highly significant values that we need to take care of. Then the third part you need to do modeling. So how the modeling can be done? To do the modeling, there are multiple process. Either you need to go through the factorization, do the hot encoding, means one hot encoding, then do some use some encoder decoder techniques, and then also you can transform all the data to specific vectors, and then train the model based on that. It can be done by multiple way. I am suggesting something else. I suggest you can try for a sequence to sequence model. So what the sequence to sequence model will do? Sequence to sequence model will give you the entire information that how this user will behave. So how the sequence to sequence model will work? Sequence to sequence model will basically identify that what are those inputs this user is giving based on multiple parameters, and based on these inputs, when I am giving the next test data based on the historical sequence, the model will identify that these are the historical sequence, and right now the user is giving this type of sequence. So if there is a match between any of the sequence, which is basically very possible if that is a biased data set, and then based on that sequence, it will give the predictive output. Predictive output in the sense, it will give the user that, hey, if you are selecting the value 85, if value 65, then for LOT area, the predictive output might be something in the range between 8,000 to 9,000. It will not give you the exact range, but it at least give you the probable range. So this can control the mind of the users, because whenever we using the model forcing the users to identify the best possible value between this range, then that is very obvious that that user will identify the value within that range at least. It is a very highly probable case based on multiple statistics. Our model will not only learn, but also let users learn that how they will give the inputs. And if the user will give the inputs right way, then we are getting all these values in a very right format in the test data set. And when this test data set we will get in a very right format, then it's very easy for any model, doesn't matter, for any model it's very easy to predict the cells. That is the next model. So here I talk about 4 different module, not model, 4 different module. First module is to identify the biasness. Second, to identify, okay, first is the biasness and the variance. Second is the correlation between multiple module. Third is the model that how can we identify, or how can we understand the sequence. And the last but not the least module is basically the final prediction, that hey, this is the final price prediction of this input that is giving by some user. So these are the 4 entire module that will give you a very good result. So how it is related to this, I am not going to relate this idea with this assignment. Why? Because in the real scenario, you are not getting this type of information, but you are taking this information on real-time basis from the users using some application, using some module, or using some other tasks. So that tasks or that Android applications or that forms can be automated based on this third module, that is a sequence to sequence module, to enforce users to give the right information in a right way. And when they are giving the information in a right way, we will get the information in a correct manner. And when we are getting the information in a correct manner, then our model will give the right output to the user. And when the user will get the right output based on their input, then the user will be happy and use our models, use our products. And when the user will use our products, that means our business will grow. That is the main goal for any data scientist, because the data scientists are responsible to grow the business, to give the strategy to the business, to ensure the proper direction to the business. And that only can be possible when we direct the users, when we can motivate the users, but in a very statistical way, in a very tactical way, that they should give us the right output, or sorry, right input, right data, because everything is based on the data. Until and unless we have the right data, then our model, no matter how good are our model, how fine our model tuned, how good our neural network is, ultimately there is a garbage in and garbage out. Just a means it's just a like means wastage of time, wastage of models, wastage of money. So no this company will invest on this. Company will invest only on those model or those projects when that will give the profit to the business. And to do that, we need to think always out of the box, out of the flow that whoever others are thinking about. So this is the very basic but very crucial point of any of a house prediction assignment or house prediction project. That is not so easy like Kaggle is doing. Kaggle is doing a very simple project, but it's not a very simple project. It's a very complicated, very critical, and very thinkful project that can be done in a different way, but in a very, very good way, where we are controlling the output, or basically we are controlling the input by the users, so that we can get the right data. So getting my point, in this data set, our y is the sales value, right? And others, all the variables are the x value, right? So we need to think of multiple things. One is that is the correlation, but also the multi-collinearity factor. That whether how much there is an intercorrelation between different parameters. If there is a high intercorrelation between parameters, then we need to take those parameters as a one parameter. Like for example, there is a very, very high valued correlation between two parameters. Then it means that those two parameters are basically highly uh, impacting the whole model or whole data set, but in a similar way. Then we can take those two parameters as a one parameter. We need to also think about the very, very negative correlations, because negative correlations are also giving the high impact to the models. So similarly, we need to take care of the very highly negatively correlations, that is significant information. Like this way, we are means minimizing the all parameters in a very, very high and very, very low, but very, very significant without any multi-collinearity factor or intercorrelations parameters. And once we take once we get that data, then that data is a very good, clean, and I can say it's a very specific information which can train our model in a very right way and give the output in a very proper way. Okay, so this is the main idea, guys. So that's why I am not going through the code again. I'm saying it's I can go through the codes like other means like other mentor or facilitator, and that I can show you the codes. I can go through each and every line of the code, but it's not actually the case. You are not a kid. You are not a like very college pass outs. You all are basically employed and working professionals. You already have those ideas, but but what you need how to solve the problem. That is the main idea. And to be to be a successful data scientist, you need that information only, because everyone is capable, and there is a Google who can give you all the data. Like in this Kaggle, you can go to the Kaggle link and you can get a lot of notebooks. What is the difference? Anyone can do that. So that's why today I give you the entire picture. That is a very, very high level but very crucial picture about the house price prediction. That is the idea from my end.
Just a quick info, guys. Test your knowledge of NLP by answering this question. To which of the following fields does NLP belongs to? A. Computer science. B. Artificial intelligence. C. Linguistics. D. All of the mentioned above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Let's begin with this artificial intelligence project on HR analytics. So this project will going to be really interesting as you will learn a step-by-step approach for working on an AI project and how actually companies uses AI for resolving their business problem statement. So the problem statement is here. Your client is a large MNC and they have 9 broad verticals across the organization. So one of the problems your client is facing is around identifying the right people for promotion and prepare them in time. So it is only for manager position and below. So currently the process that they are following is first one. They first identify a set of employees based on recommendations and past performance. Then the selected employees go through the separate training and evaluation program for each vertical. These programs are based on the required skill of each vertical. Then at the end of the program, based on various factors such as training performance, KPI completion, employees gets promotion. So talking about the KPI completion, so only employees with KPIs completed greater than 60% are considered. Now this is the actual problem statement. Now let us look at the scenario that is provided by the company. So the final promotions are only announced after the evaluation and this leads to delay in transition to their new roles. Hence the company needs your help in identifying the eligible candidates at a particular checkpoint so that they can expedite the entire promotion cycle and they can speed up the process actually. So the first thing is they have provided multiple attributes around employees' past and current performance along with demographics. Then they have provided multiple attributes around employees' past and current performance. Now the next and the second point is the task that we have is to predict whether a potential promote at checkpoint in the task set will be promoted or not after the evaluation process. Now this is what we have to do, and moving ahead, let's understand the data set and the parameters. So let me go to the training and the testing data set. Now this is our training set and this is our test set. So now let me go to the training set and this is the employee ID. So we are not much concerned about the employee ID, so it will not actually help us in the prediction. This is the department section including sales and marketing, operations, then technology, analytics, operations, sales and technology, again technology, then research and development, then there is finance, procurement, and so on. There is also a department called HR, and the next one is region. So this is region 7, region 22, region 19, and there are many regions. So region will actually not help us to predict the outcome of the model that we have to build. Then comes education. So education can be the factor for predicting the promotion. So the list of education that is provided over here is masters and above and bachelors. So also here the empty data is there, which means that there is no data provided over here. So we will deal with the missing values also. And then comes the gender. So the gender is male and female. After that comes the recruitment channel, that is sourcing and other. Then comes the number of trainings. So that is 1, 2, and we'll scroll down. It includes 3, the number of training that are provided to the individuals or the employee. Then the next thing is the age. So this is the age of the employee. Then comes the previous year rating. So this can be one of the most important factor in the promotion. So the previous year rating is 5, 3, 1, 3 and so on, and this position or this, so this is 3-star, 4-star, and this is empty. So it denotes that the employee is not at all having a rating. So it can be because the employee may be a fresher. So let's check out the length of service. So here the length of service is 1. So that is why the previous year rating is not shown over here. So we'll sort out this thing also for making the model more accurate. Then comes KPI metrics, that is key performance indicator. So it denotes and it indicates the metrics for the performance of the employee. So 0 over here denotes that the performance is not at all good for giving them promotion, and 1 indicates that the performance is decent enough to give the promotion. Then comes awards 1. So this is 0, 0, 0, and here it is 1. So award 1 is 1 over here for a particular employee whose ID is 77981. And now average training score. So this is the training score of an employee while pursuing a training for the company. Here it is 85, 73, starting from 49, 60, 50, and so on. So it can be a major factor for predicting the promotion for the employees, that is how well they perform in the training and what is their score in the training. Then comes is promoted. So 0 means that they are not promoted and 1 means that they are promoted. So in this data where the promoted thing is 1, so this is the average training score, and here this shows the KPI metrics, that is also 1. Then the next one is the length of service, that is 6 years, and so on. So these are the parameters and the data set on which we'll be working on for making an AI model to resolve the business problem. Now let me go to the training set. So this is the training set, and it consists of, let me go to this part. Okay, so this also consists of employee ID, then department, region, education, gender, recruitment, number of trainings, age, previous year rating. Then comes length of service, KPI metrics, awards 1, and then average training score. So these are the parameters over here. So we have divided the data set into train and test set so that we can train the model using the train set, and we can test the model using a separate data set, that is HR underscore test. Now the reason for using the test and the train data for the model is that we do not want our model to overfit the data. So in future it may get different sets of data and it may face issues in giving accurate results because the model is overfitting the data set that it is having. That is why we are using a separate data for training the model and a separate test data for testing the model. Now we have understood the data, that is trained data and the test data. Now let us move on to the steps that we'll see further. So the next step that we'll be going through is pre-processing and feature engineering. So in this we'll pre-process the data with using the different types of pre-processing. That is, we will manipulate the data, we will remove the null values and the missing values from the data set, and before that we'll use various and we will import various types of packages that are required for the implementation, and we'll see the info of the train and the test data set as well as the description such as the standard deviation, the mean and the average of the values. Then we'll perform feature engineering for the model and for the dataset values. Then we'll build the model using various algorithms that are used to build AI based applications, and we'll apply feature scaling so that all the values comes in the common slot and the prediction becomes more. And finally we'll evaluate the model that is created using various parameters and metrics of model evaluation, and then we'll visualize it using models visualization. So further, let's go to Google Colab for the implementation part. Now this is our Google Colab. So first thing you have to do is just go to this folder option, click on this upload session storage button and upload the training and the testing dataset. So I have already uploaded it, so I'll just show you. So I'll scroll down and here is the data, that is train and test data that I'll be using. So whenever you open Google Colab, so the first thing you have to do is you have to load the dataset. Otherwise you cannot work with Google Colab and create algorithms and AI based applications. So also one thing more, if you load the dataset now, so it is for this instance on which you are working. If you will close the tab, then the dataset will be deleted. So again and again you have to load the dataset. Now I have written the code over here, the entire code. So I'll implement and I'll explain every code, what it is actually built for and how it is working. So first I'll import warnings and use this warnings.filter warnings ignore. So this is used to ignore the warnings that are displayed by the interface or by the Python library while implementing the program. So I'll run this and now you can see it has been successfully executed. Now the next thing is the scientific and data manipulation libraries. So I have imported pandas, I have imported NumPy, then import math, GC, OS and the sklearn package. So we use pandas basically for data analysis and data manipulation, and it provides various features for the analysis of data. Then comes NumPy, so we can work with multi-dimensional data and matrix arrays using the NumPy library. Then comes importing of maths that help us to implement various mathematical operations. After that, import GC for the garbage collection, and then importing OS so that the packages and libraries are imported so that the application which we are building using the various modules and libraries of Python, so it gets added according to the operating system. Then importing scikit-learn, that is sklearn. So scikit-learn basically help us to implement classification, regression, dimensionality reduction and many other machine learning algorithms we can implement using the sklearn or scikit-learn library. So I'll run this, and now the installation of the scikit-learn is done. So I have already done. It may take a while for you to get this. So I'll run this pip install scikit-learn to install the scikit-learn library. So it will take a while and it will get loaded. So these are the basic steps that you need to implement before data pre-processing. So these libraries and packages are the first thing that you have to load and install or download for working further with the data pre-processing task or creating algorithms. Then comes more libraries. So in sklearn we have pre-processing, model selection, tree, ensemble and metrics. So from sklearn library we import the packages for pre-processing and model selection, tree, ensemble and metrics. So why we do that? Because we have to use label encoder, one hot encoder. We want to use min max scaler, normalizer, robust scaler. Then comes max absolute scaler, and then we used model selection thing for using k-fold, stratified k-fold, train test split, then cross validation score. After that comes the tree package, for which we have to use decision tree classifier, random forest classifier and then voting classifier using the ensemble package of sklearn library. Then comes the metrics package of the scikit-learn library, using which we'll evaluate, or first we'll load F1 score, then confusion matrix and classification reports that help us to implement the functions for F1 score, calculating confusion matrix for accuracy and the classification report. So we'll use this from sklearn.preprocessing, import standard scaler, min-max scaler, normalizer, robust scaler, and for loading all these modules from the library, we'll use these commands. So let me run this. So it shows that it is successfully executed. So before moving ahead, let me explain you the standard scaler, min-max scaler. So all these, why we are actually using it. So starting with standard scaler, it actually removes the mean and scales each feature or variable to unit variance. And this operation is performed feature-wise in an independent way. So standard scaler can be influenced by outliers. So the values lying beyond the common slot of area where the actual values are lying, so it can be influenced by the outliers, and it involves the estimation of the empirical mean and the standard deviation of each feature. So it scales it, so it helps the model to predict in a better way. Then comes min-max scaler. So min-max scaler rescales the data set such that all the feature values are in the same range from 0 to 1. So actually there are too many values and it can have different values from 1 to any of the value. So we need to rescale the value in a common slot such that we can create a plot out of it and gets a better visualization. So min-max scaler helps in this way. After that comes the normalizer. So the normalizer rescales the vector for each samples to have unit norm independently of the distribution of the samples. Now then comes the robust scaler. So unlike all the other scalars, the centering and scaling statistics of this scalar are based on percentiles and therefore they are not influenced by a few number of very large marginal outliers. Then consequently the resulting range of the transformed feature values is larger than for the previous scalars, and one of the most important thing to note is that they are approximately similar, and for both features and for most of the transformed values they actually lie in a range of -2 to 3. Now coming to max ABS scalar, so it differs from other scalars and such that the absolute values that are mapped, they are in the range of 0 to 1. So they are the absolute values, and on the positive data the scalar behaves similar to min-max scalar, and therefore it can suffer from the presence of large outliers. Then comes the voting classifier. So the logic behind the voting classifier is creating a separate dedicated model and finding the accuracy for each one of them. So we actually create a single model that is trained by the other models and predicts the output based on their combined majority of voting for each output class. So that is the logic behind the voting classifier, and we'll use this voting classifier for our project. So I hope the importing of the libraries and packages is clear. Now we'll move ahead and we'll import class and we'll install the cat boost. So I'll click on it. So you have to use this command pip3 install cat boost, as we'll be using the boosting algorithms such as xgboost, lightgbm and cat boost for preparing our model. So it will just take a while to load, and I have already loaded this and I have downloaded the packages related to cat boost. That is why it is showing requirement already satisfied. Then I'll import the xgboost and use an attribute that is xgb for it. Then lightgbm and then cat boost. So I'll click on it and it is successfully executed. So why do we actually use xgboost, lightgbm and cat boost? So xgboost is a scalable and accurate implementation of gradient boosting machines, and it has proven to push the limits of computing power for boosted trees that are used for implementing the algorithms for the sole purpose of checking the model's performance and improving the model's performance and the computational speed. So that is why we use xgboost. So also xgboost is used for supervised learning problems where we use the training data to predict a target variable. So that is why xgboost is used for building the AI models. Then coming to lightgbm, that is a gradient boosting framework that uses tree-based algorithms, and it is designed to be distributed and efficient with the following advantages, that is faster training speed and higher efficiency. Also it has support of parallel and GPU learning capable of handling large scale data. So that is why lightgbm is used as a classifier. Then coming to cat boost algorithm, so it is an algorithm for gradient boosting on decision trees. So it is basically used for search, recommendation systems, personal assistant, self-driving cars, weather prediction and many other such tasks. So one of the major benefit of using cat boost is it can handle missing values internally. Also by default cat boost uses one hot encoding for categorical features with a small amount of different values in most of the modes that we use. And so coming to one hot encoding, we use it for all the categorical features with a number of different values less than or equal to the given parameter value in a specific range. So we'll use all these algorithms for our AI project, for building our model, and I hope you are clear with the algorithms that we are using. So let me run this, and you can see it is being successfully executed. Now I'll run this. That is, from XGBoost we are importing XGBoost classifier. So it is also successfully loaded. Now comes the data visualization libraries. So we will use matplotlib, seaborn and plotly package for the data visualization. So I'll run this. Okay. Now comes the randomness of the data that is being selected. So we'll use np.random.seed. So it is actually used to save the state of a random function so that it can generate same random numbers on multiple execution of the code on the same machine, or it can be on different machine. So the seed value is the previous value number generated by the generator. So that is why we'll use this np.random.seed. After that, we have to set the location path from where we'll use the dataset. So we have already loaded the dataset, and you have to do it again and again for the Google Colab if you are using Google Colab. So now I have already imported OS. So it is just written over here, from Google Colab import files, then train pd.read.csv is used to load the dataset. I'll run this and let us see. Okay, so it is being successfully executed. Now we'll display the dataset of train and test. So we use this display function to display the values. So I'll run this and it will display the training values and the testing values. So let me scroll down. So the first one is training value and the second one is the test values. The second one are the test values. So this shows the index. Now employee ID, department, region, education, gender, recruitment channel, then number of trainings, age, previous year training, length of service, KPI metrics that is greater than 80, and awards 1, average training score, and is promoted. So as we have already discussed the training dataset, and the KPI metrics should be greater than 80% to get the promotion. So here it is. Now let us check out the test dataset. So again, these are the index, employee ID, department, region, education, and it will not have the is promoted column because this is the testing dataset. That is, these are the independent variables using which we have to predict whether the person has to be promoted or not. That is the variable is promoted. Now further, let me go to the exploratory data analysis that we have to perform. So for this, first we have to look into the information of the training set. So for this, we'll use train.info to display the information of the trained data. So let me implement this.
Just a quick info, guys. Intellipaat provides NLP training using Python mentored by industry experts, the course link of which is given in the description below. Now let's continue with the session.
And now we get the training data. Along with it includes the non-null count and the data type. Also the count of the types of data type, that is float 64 is 1 time for the corresponding column, and it is previous year rating, and integer is 8 times and the object is 5 times. Also it shows the memory usage, that is over here it is 5.9 plus MB. So this shows the information related to train set, and then let me display the information related to the test data. So here it shows that there are 23,490 entries starting from 0 to 23489, and data columns total there are 13 columns, and non-null count along with data type and the count of data type over here, and the memory usage is 2.3 plus MB. So this is the information regarding the test and the training data. Then comes displaying the descriptive statistics of train data. So just talking about exploratory data analysis, so it is a part of the data pre-processing. where we actually gather the information related to the data. So we check the info, we check the description of the data, such as the average, the maximum and the minimum values, along with the mean or the standard deviation, the type of data, memory usage, and the non-null count, and many other factors. So we look into that in this data pre-processing step, or you can say the EDA, that is exploratory data analysis. So let me run this train.describe. So it shows more information related to the training dataset. So it shows the count, it shows the mean for all of these columns, then comes the minimum value, maximum value, and the interquartile range. Now let me check the description about the test data. So I'll run this, that is test.describe. Again, it shows the count, the mean, the standard deviation, minimum and the maximum value, and the IQR, that is interquartile range. So this shows us the description of the train and the test data. Now further we'll display the number of unique values and the actual values. So we have to first define a function, def for defining the function, that is display unique, and it will take the argument as data. So here we have passed the argument of train data. So display unique, we have called the function. Now what does this function do? So for column in data dot column, that access the columns present in the data set. So we have to print the number of unique values in the column, that is the column corresponding to the trained data set that we are accessing to. Then the columns are, then using the str function data, then column dot n unique, it will fetch the unique values from the data set or from the column. Then the actual unique values in column. So again, now further to get the actual values, so here we use again the str function and then the sort values function that sorts the data in the ascending order, because the ascending is set true over here. So for getting the actual values, we have to use this sort underscore values function, and this na underscore position takes two strings, input last or first, to set the position of null values, and accessing this unique function gives the unique values from the data set. So it shows the number of unique values simply, and using the sort values function we can access the actual values in the column. So let me execute this.
Just a quick info, guys. Test your knowledge of NLP by answering this question. Which of the following includes major tasks of NLP? A. Automatic summarization. B. Discourse analysis. C. Machine translation. D. All the mentioned above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And now here we get the output. So number of unique values in employee ID are 54,808. So starting from 1 and it goes till this index. So these are the actual values, and then comes the number of values or unique values in department column, that are 9. But the actual unique values in the department column are analytics, finance, HR, legal, operation, procurement, R&D, sales and marketing, and technology. So the actual values are shown over here. So these are the actual values. So this is how we actually access the actual values using the sort underscore values, and we can keep descending also over here, but we have kept ascending order. So these are the actual and the unique values for all of the columns of the train data set. So we can check it for test, but we'll leave it for now. And now we'll move on to displaying how each feature is related to the target variable in a flow. So for this we will use a plot using the parallel categories diagram. So the parallel categories diagram actually it is also known as parallel sets, and it is a diagram, or you can say a visualization of multi-dimensional categorical data sets. and each variable in the dataset is represented by the column of rectangles where each rectangle corresponds to discrete value taken by that variable. So here we pass in the columns. So the columns are department, education, gender, previous year rating, KPI metrics, then recruitment channel, and is promoted, and color is based on the is promoted column. Then we use the continuous color scale. So using this sequential.agrenil, so we plot the figure using multiple colors. So this figure.show help us to show the figure. Now let me implement this and let us have a glance at the figure that we get. So it will just take a while to load. Till then you can just wait. Okay, this is the figure that we had. So this figure is very descriptive and it shows you the data. So let me show you how you can actually read this figure and how actually you can understand the various dependent or independent variables from this figure. So there are columns named department, then education, gender, previous year rating, KPI metrics, recruitment channel, is promoted. So is promoted is shown over here. So it consists of the value as 0 to 1. So hence its scale is from 0 to 1. And then comes the individual categories of the columns. So in department, there are multiple departments such as sales and marketing, operations. So this section is the operations one. So you can see when I have kept my pointer over here, so it shows the relation, actually the data relation from other columns such as education, gender, previous year rating, KPI metrics, recruitment channel, and is promoted. So the count it shows is 11,348. That is, there are 11,348 employees for the operations department. When I kept my mouse pointer for sales and marketing, it shows the count as 16,840. And then comes the count of this sales and marketing, and then technology. So the count is, let me click on this. So the count is, you can see over here. So this shows the count as 7138. Then comes analytics, that is 5352, R&D, which is the least, and then procurement, finance, HR, and legal. Now coming to education. So when I kept the pointer over here, so it shows the count for the masters and above degree as 14,925. So here the category is written over here. Then when I came to this bachelor's, it shows the count as 36,669. Then coming to below secondary, it is 2,409. And then the final one is the below secondary one, and this, so this last one is the below secondary one, that is 805. Now coming to gender, then the count is 16,312, and the count for the male employees is 38,496. Now previous year rating starting from 5. So the employee who are having the rating as 5 are 11,741. Then 3, rating of 3 is 18,618 employees are having a rating of 3. Then 1, it is 6,223. Then rating of 4 is of 9,877 employees. After that, the rating of 2 is 4,225. Now the KPI metrics greater than 80. So for 1, that is the metric, KPI metrics is greater than 80, the count is 19,291. And for the employees for whom the KPI metric is less than 80% are 35,517. Now again, the recruitment channel is sourcing, other, and referred. So for sourcing, it is, the count is 23,220. Then for others, the count is 30,446. Then for the referred one, it is 1142. That is the least. Now I'll come to the is underscore promoted column. So the count it gives is 50,140 people are not promoted, that is the value is 0, and the promoted people's count is 4668. So you can see over here the structure of the figure. Now for the next one, we will have a heat map. So we will display the correlation between the features through heat map, and lighter color higher correlation, and if close to 1. So lighter color shows the high correlation. So for this we use sns.heatmap, and as we are making the heat map for the train dataset, so we'll use this train.corr for correlation, and this annotation or anot is true. So I'll run this and we'll get the heat map. So here are the employee ID. So these are the columns: employee ID, number of training, age, previous year rating, length of service, KPI metrics greater than 80%, awards won, and then average training score is promoted. And this scale shows the is promoted thing starting from 0 and 1. So the values are only 0 and 1. Now the x-axis of the figure, so it is not actually x-axis, but it is the other side of this figure. So it has again employee ID, number of trainings, age, and previous year rating, length of service, KPI metrics, then awards won, and average training score, and is promoted. So a heat map is a two-dimensional graphical representation of data where the individual values that are contained in a matrix are represented as colors. And the Seaborn library, we have imported it for this purpose, and the Seaborn Python package allows the creation of annotated heat maps, and which can be tweaked using the matplotlib tool as per the creator's requirement. So we are creating this for the correlation, finding the correlation. So this color shows us the correlation between all these parameters that we are evaluating. So this is the heat map that shows the people who are promoted, or not the people who are promoted, but the correlation between these columns. Now let me go to the next part, which is finding the duplicate rows from the trained data if it is present. So we have to check for duplicate rows to remove them. So we will create a method that is remove duplicates that will have an argument of data. So in this we'll print before moving or before removing duplicates the number of rows, comma data.shape. We'll give the argument as data.shape. Then we have to implement the logic or the action, that is data.drop duplicates. To drop the duplicates, keep equal to first in place equal to true, and then again we have to print after removing duplicates the number of rows. So again the argument is data.shape. So actually this data.shape returns the data in the form of array, and then we'll return the check duplicates. And now I'll just implement this, run this, and now I'll call the remove underscore duplicate and give the data or the argument as train. And now I'll click on this. Further, after the successful execution of the code, we'll get this: before removing duplicates the number of rows are 54,808, and after removing the duplicates the number of rows are again 54,808. Now it will return the checked duplicates. After that we'll handle the missing values. So remember that still we are in the data pre-processing or the manipulation part, so we have to deal with the missing values. So missing values are present in the previous year rating and education columns in both train and the test data. So here I have just written for the reference why is data missing in column previous year rating. So data was not entered because those employees were fresher. So as I have already told you when we were discussing and when I explained you about the data set, so data was not entered because those employees were freshers, that is length of service is 1 is equal to 1 and they did not have the previous year rating. So the no data would have been there in the data source itself for these employees. So logically we are imputing with 0 as freshers with 1 year experience and may not have previous year rating at all. So filling the missing values in train and test data. So what we'll do is we'll use this train dataset and the test dataset, and in this bracket we'll give the column name, that is previous year rating, and what we'll do is again to access the previous year rating, so we are actually accessing the previous year rating and then we'll use this dot fill na with 0, so it will fill those values with the 0. So the next thing is we'll access the column of fresher for the train dataset and then we'll use this previous year rating and apply function, and then we'll use this lambda. So here we'll put the condition, so if x is equal to 0 is equal to 0, then the employee will be a fresher, otherwise the employee is an experienced professional. After that we'll display the fresher column with the value counts and again the previous year rating, length of service and this fresher tag that we have used using the condition that is applied over here for marking the tag as a fresher. Again we'll use this display function to display this previous year rating, length of service, then fresher for the first 25 values and for this we'll use this head function. Now I'll run this and here we get the output. So these are the columns and they are replaced by values as 0, 1 fresher. So this is the fresher column and this is the fresher tag that we have displayed using the display function and putting the condition over here. So the experienced professionals are 50,684 and the freshers are 4,124 and the data type is integer again. So we have used the previous year rating, length of service and the fresher column for displaying the data. Now again we have displayed the data for previous year rating, length of service, and this tag I should have changed it to experienced. So okay, so I have put a condition over here, so let me go to that one. Okay, so here if x is equal to 0 then it will be a fresher, otherwise experienced. So that is why it is showing data over here for experienced as well as for fresher, and the length of service, previous year rating. So this is actually about the removal of the missing values and sorting out the missing values that were there in the data set. So we actually saw some empty blocks in the data set, so we filled in with the values as 0. So for that we used fill na and filled with 0. So this is done. Now next what we'll do is we'll display the missing values in the train and test data. So to display that we'll use this display function and this will give the text as train corresponding to the missing values in train set. So we'll use this train dot isNull dot sum. So isNull for counting the for getting the null values and sum function to sum all those, and to display it we'll use this display function. Same for the test. So I'll run this. So for training set, so this is employee ID, department, region, education, gender, recruitment channel. So for all other columns the null values, so there are no null values, there are 0 null values, but for education there are 2409 null values present. And for the test column, the employee ID, department, region, and all other columns are not having any null values. The count is, or the sum of those null values is 0. The count is 0. And for the education, it is 1034. So as the test dataset is less than the training dataset, so it is showing less. So we have counted the null values over here. So now after executing this, let us handle the null values. So for this we'll use ffill, bfill. So I have written this for reference, so you can read this. So talking about ffill, so this is forward fill, that fills the missing values with previous row value. And if previous row value is null, then it moves to the next element without filling. That is why we use ffill and bfill both. So what does bfill do is, so it is backward fill that fills the missing values with next row value. And if the next row value is null, so it moves to the next element without filling. So what actually happens is, for example, for just explaining you, if the system goes to 4th and 5th row and the 4th one is empty, then it iterates to the 5th row and fills the data of the 5th row into the 4th row. So this is actually the backward fill. And in forward fill, what happens is it fills the missing value with the previous row value. For example, if 4th row is having a data and 5th row is empty, the data is not present, then the value present in the 4th row will be added for the 5th row data. So we use both forward fill and the backward fill to fill in the data. Also, filling with mode and new category called others are most commonly used technique which didn't work here, so we are not using that. So we can assume that while collecting data relevant members, data were collected close to one another, so it is not too fluctuating, that means. So talking about the training, now we'll fill in the values for the education column. So here we have used this train, inside it we have given the argument inside the square brackets as education. Then we'll use this dot ffill for forward fill, and we give the argument in this way, that is access is equal to 0 for all of the train and the test data. And finally we display the data and we try to actually calculate the sum of all the null values that are present in the training data set and the test data set using the isNull and sum function. So I'll run this and let us see the output. So it will just take a while to load. So here we get the output for the train and the test data set. So employee ID, department, region, education, gender. So you can see over here, so we have implemented it on the education column by using the forward fill and backward fill. So the count has come down to 0 for the education column. Now after this we'll work on feature engineering. So based on the age distribution, most of the employees are in the range 20 to 40 who will be also waiting for a promotion. And so we have created 2 bins, 20 to 29, 29 to 39, and remaining 1 bin for 39 to 49. So we have used dist plot, so plot a univariate distribution for the observations. So I have written this for the reference so that you can refer it in future if you have any doubt and all. So you can see the description of this. Okay, so moving ahead, we'll use this sns.distplot and we'll give the train as the data and this age column, and after that we'll use this train, and inside this square brackets we'll give the age. We'll use this pd.cut and give in the argument as train and the age column. So the train data set along with the age column, or for the age column, and bins will be 20, 29, 39, 49, and labels that would be given to these bins are 20, 30, 40. Same for the test one. For each column, pd.cut. Pins will be 20, 29, 39, 49, and the labels will be given as 20, 30 and 40. So let me run this, and now we'll get the plot like this. So feature engineering is nothing but extracting the feature or the properties from the dataset and the expertise and the knowledge that we have. So this is the plot that we have after plotting the age column. Now after this, we'll split the train data into predictors and the target, that is independent and dependent variables. So this is the step that we have to do before creating our model. So here we'll split train into x underscore train, that is features, and y underscore train, that is target. So in x train, we'll select all of the columns, that is department, region, education, gender, recruitment channel, number of trainings, age, previous year rating, length of service, KPIs, metric, that is greater than 80%, awards won, and average training score. And in this Y train, we'll select the is promoted column, that is the separate column that we have to predict using the test dataset. So we will add this in the Y train section, and then we'll convert the Y train into a frame using 2 underscore frame, because it is a single parameter and the output is expected to be in data frame. So we'll use this to convert it to a frame. Now comes the X test. So we'll use this X underscore test, and inside it we'll give the argument or the number of columns, that is department, region, education, gender, till average training score. So now we have successfully splitted the train and the test data. So after running it, so it has no error, that is it has been successfully executed. Now as we have splitted our data set into train and test, now we'll perform the data encoding using the label encoding and the one hot encoding. So what does it actually mean to perform these operations? So actually label encoding refers to the converting of the labels into numeric form, so that to convert it into the machine readable form, and the machine learning algorithms or the AI algorithms that we are using for building our AI based application can then decide in a better way on how those labels must be operated. And using one hot encoding allows the representation of categorical data to be more expressive, and many or the various machine learning algorithms cannot work with categorical data directly. So the categories must be converted into numbers. So this is required for both input and output variables that are categorical. So we use one hot encoding for that. So we'll define a function that is data encoding, and given the parameters or the arguments, that is encoding strategy, encoding data, and encoding columns. So let me go down and check where I have called this. Okay, encoding data encoding. So I'll check where I have called this function. So this is data encoding I've called over here, then encoding strategy, and then the data, then the columns that we have to give. Now I'll go back over here. Now what does this function do? So if encoding strategy is label encoding, then we have to print if label encoding, and the encoder we have to put in the label encoder because we are using label encoder. And then we will put a for loop over here. So for column in the encoding columns, we have to print column, then encoding data, and in this encoding data the column will be inserted, and then this function has to be executed. So encoder.fit transform, and then the argument must be given. So tuple encoding data, again we'll use the column as the argument. After that, if this is not true, then we put in elif condition where encoding strategy is equal to one hot encoding. So if this is the scenario, then we have to print elif one hot encoding, and then encoding data we'll use pd.getDummies for encoding data. So this is This PD is the instance of the pandas library, and this get dummies will give us the categorical values, the dummy categorical values. And after that comes the d-type list that we have to define for float 64, float 32, int 64, int 32 for the data type. So this is the data types list. Then encoding data as type will use, and then data types list, and then we'll access the data types. So after implementing if elif, these two lines of code will be implemented which shows the data type, and then return encoding data. So using these condition we'll implement the data encoding technique. So here for description I have added this quote and many points related to it. So let me read it for you. So applied one hot encoding, it will be applied to object categorical columns only, and it's most common to one hot encode these objects columns since they can't be plugged directly into most models. Then pandas offers a convenient function called getDummies to get one hot encodings. So using this getDummies we get a dummy variable or a dummy value for the categorical or for the encoded values. So get this using getDummies, and many machine learning algorithms cannot operate on labeled data directly. Then they require all the input variables and output variables to be numeric. This means that categorical data must be converted to a numerical form, and a one hot encoding can be applied to the integer representation. Finally, this is where the integer encoded variable is removed and a new binary variable is added for each unique integer value. So you can go through this description for the reference. So I'll run this. So it has been successfully executed, and you will get the result in the next code when we'll implement it. So just for reference or example, I have added the data encoding for this color, that is red, blue, green, red, blue, green. And I have created this df as the data frame, and then pd.data frame. I have given the data over here columns as color. Then I'll print before one hot encoding and call the function as display df, and then I'll print after one hot encoding and display pd.getDummies. So for the first one, so we get the result as before one hot encoding, it is displaying the data frame, and in the second one we get the result after one hot encoding. So I'll run this in one go. So let me explain this one also. So encoding columns, encoding strategy. So I'll go in this code. So we have created a function data encoding, and the parameters are encoding strategy, encoding data, encoding columns. So over here are encoding columns, encoding strategy. So encoding strategy is label encoding, one hot encoding, and the encoding columns are region, age, department, education, gender, and recruitment channel that we have to encode. So while implementing this, we have to just give in the index. So here I have called the data encoding function that we have defined earlier. So xtrain encode, xtest encode, and we have called data encoding and data encoding strategy. So index is 1, and the data is xtrain and encoding columns. So it will take the entire column, so all of the columns, and then the second one is encoding strategy xtest on xtest and encoding columns. So it will take all the columns. Then for displaying the encoded train and test features, we'll use the display function, and we'll display the first few values using the head function. So xtrain encode, xtest encode. So let me run this, and the first one gives the color data frame, that is red, blue, green, red, blue, blue. So these are encoded in 0, 1, 2, 3, 4, 5. So we have performed one hot encoding, and after performing one hot encoding we get the following results. that is color blue, color green, color red. So these three are the colors: red, blue, green, and these are the indexes, and the encoding that is done is.
Just a quick info, guys. Test your knowledge of NLP by answering this question. To which of the following fields does NLP belongs to? A. Computer science. B. Artificial intelligence. C. Linguistics. D. All of the mentioned above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So this is the data frame. So we have converted it into a data frame. That is why it is showing a data frame over here. So color blue, color green, color red. So this is these are the encoded values for it. Now let me go up and let me check. So this was the color part, and then we defined the encoding strategy. Then we have called data encoding 2 times for train and test, and it is showing one hot encoding. So it has performed one hot encoding. So why it has performed? Because the index that we have given over here is 1. So here it is 0, label encoding is 0, having an index of 0, and one hot encoding is at the index position 1. So one hot encoding will be performed. So for performing one hot encoding, first it will print LF one hot encoding that shows that it is performing this type of encoding, and then it has performed the one hot encoding using the pd.getDummies. So it is displayed over here. So these are the result for the encoded rows, the columns that are over here. So you can check it out, the encoded values. So we have encoded it for region, and then it shows various region and the values, then for gender, recruitment channel, and so on. After that, after the encoding has been performed, so our data is encoded, and now we have to perform scaling. So we have already discussed about the scaling types, that is robust scaler, standard scaler, min-max scaler, and max ABS scaler. So I have told you about these type of scalars. So we will directly create a function, so using this data underscore scaling, and we'll give the argument name as scaling strategy, scaling data, scaling columns, and we'll give in the condition as if scaling strategy is robust scaler, then the scaling data will be, and inside this square brackets we'll give the scaling columns that we need to scale, and then we'll use the robust scaler dot fit transform to scale the values using the robust scaler, and then the scaling data which we have used and we have passed in the argument, and the scaling columns that we need to scale. Same with the standard scaler. So we'll give in the condition as LF. So scaling strategy, if scaling strategy is equal to standard scaler, then we have to use this standard scaler dot fit transform, and again the scaling data along with the scaling columns, or you can say the corresponding scaling columns that we have to put in over here. After that, again LF scaling strategy is equal to min-max scaler. Now same with the min-max scaler and max ABS scaler. So scaling data, then scaling columns, then again using the fit underscore transform method and given in the parameter as scaling data with the corresponding scaling columns that we need to scale. And final else condition consists of the robust scaler. So if any other scaling sent by mistake, it still performs the robust scaler. So we'll use the same line of code that we used for robust scaler, that is scaling data, corresponding columns, and then robust scaler function dot fit underscore transform, and finally we'll return the scaling data. So I'll run this and let's check. Okay, so it has been successfully executed. Now the next one is where we will call the data scaling function or the method. So this is the data scaling method that we have created over here. So this is the description that I have given for reference. So let me read for you. So robust scaler is better in handling outliers. So standardization of a dataset is a common requirement for many machine learning estimators, and typically this is done by removing the mean and the scaling to unit variance. And the outliers can often influence the sample mean variance in a negative way. So in such cases, robust scaler, which uses the median and the interquartile range, often give better results. So here we have defined the scaling strategy. So that is robust scaler, standard scaler, min-max scaler, and max ABS scaler. Now we'll use this X train scale and X test scale as the variable or the instance, and we'll store the values after calling this method, that is data scaling. We'll pass the argument as scaling strategy, that will be 0 in the first one and 0 in the second one. So 0 indicates that it is calling the robust scaler. So we have created the scaling strategy and we can call any one of this. So we have called the robust scaler. Then here we have given the X train encode and then X train encode columns. So what it actually shows is we are scaling the encoded values of train and the test dataset that we have encoded in the previous steps. Okay, then we'll display this X train scaled value and first few values of it for the train and for the test. So it should be test over here. Now let me run this and let us see what we get as the output. So this is the number of training previous year, length of service, KPI, metrics, award won, average training, department. So now we have successfully scaled the values using the robust scaler. So what actually is robust scaler doing over here? So you already know. So it is handling the outliers and it is making the model more accurate and helping us to create such a model to give more precise results. So this is done. Now comes the most important step, that is creating baseline ML model for binary classification problem. So we will use some machine learning algorithms, and you can also say that AI algorithms. So we have already looked around it earlier, that is XGB classifier, then cat boost, light GBM. So here we will create a dictionary, that is key value pairs for ML model name, and then ML model functions with hyperparameters. So these are the hyperparameters. So we'll given the name as classifier, and at the 0th index we'll give the XGBoost. First will be cat boost, second will be light GBM. So using this XGB classifier, we'll define the hyperparameters, that is learning rate, N estimators, max depth, subsample, verbosity, scale, position weight, updater, base score. So the learning rate over here is 0.1. The number of estimators are 494. Maximum depth is 5. Subsample is 0.7, that is 70%. Then verbosity is 0. So what actually verbosity is? So verbosity in keyword it arguments, and it usually means that showing more wordy information for the task. So actually giving the more description. Then the scale position weight, that is 2.5. Updater is grow hist maker, then base score is 0.2. So we'll see the plot which will be plotted. Then it will be same for the cat boost classifier, learning rate, number of estimators, subsample, max depth. Then for light GBM, the importance type come in for extra. Then verbosity is -1. So you can see over here the verbosity is -1. Here it is 1 or 0. Sorry. So here it is 0. Here it is 1. So the more is the verbosity, the more wordy or the descriptive is the model, or you can see it is more adaptive and it shows the more information. So here it is -1, so it is low. then maximum number of bin is 60, number of leaves 300, boosting type is Dart, learning rate is 0.15, number of estimators are again 494, max depth and other things are same as the cat boost and xg boost. Now after creating a dictionary, after creating baseline ML model for the binary classification, we'll print. So we have to use this list, then classifiers dot keys and classifiers dot values for it. So after implementing it, let us see what we get as the result. So xg boost, cat boost, light GBM, and this is what we get. Now our model is created and there are so many parameters to evaluate it. So base score, booster, column sample by level and so many others, but we need to improve our model as no model is perfect in AI or machine learning. So what we'll do is we have to improve the machine learning or the AI model. So as we have used this machine learning algorithms, so it is same for AI also. So I have written over here the ML model. So to improve the ML model with voting classifier, with model evaluation metric, we'll use this F1 and predict target for S promoted. So we'll evaluate the F1 score. So actually what voting classifier is, we have already discussed in the previous section while importing the libraries, modules and packages for the voting classifier. So we'll use the instance or the variable as voting model, and then we'll use the keyword that is reserved by the library or the package, that is voting classifier, and the estimators will given as the xg boost, and then the second argument will be then list classifiers dot value to fetch the values, and for 0th index is the 1 for xg boost, and the 1 or the first index is for cat boost, then light GBM. Then we have given over here as soft voting, and the weights are given over here 5, 5.2, 5, 5 and 5.2. So actually in soft voting the output class is the prediction based on the average of the probability given to that class. And you can consider an example. Suppose you are given with some input for the 3 models and the prediction probability for class 1 and class 2. So if the probabilities are 0.1, 0.2, 0.3, and for the next one it is 0.2, 0.3, 0.4. So obviously the average of the second class is greater. So the winner is the second one. So this is the soft voting that we call in machine learning. So it is given over here. So then we'll use this voting model that we have created and use this fit method, and inside it we'll give the parameters as xtrain scale for the scaled values that we have created in the data engineering process, and we'll give in the y train for training the model. Then we'll evaluate the predictions of the voting using the voting model that we have just now created dot predict probability, and we'll give the x test scale for checking the performance of the model on the basis of test dataset. So we'll take the entire test dataset. So let me run this, and it will just take a while to get executed. So now get the output. So you can see over here, so the learning rate and the total time, remaining time. So you can see it is still executed. Now again it will take time, so let me tell you the next part that we'll implement. So next we'll work on the result, we'll see the result and try to improve the F1 score. So for this we'll, okay, it is completely executed. We see the values. So it took a total of 10.4 seconds, to predict the outcome or to learn the features of it. Then the next part that I was talking about is the result and the improving of F1 score. So for this we have to round off the probability results, and for this we'll simply use an instance as prediction, and we'll give in the round function, and before it we'll use the integer that converts it to the integer, and then we'll have a for loop. So for value in predictions of voting that we have just now implemented for the voting model or the voting classifier, so predictions of voting will be counted over here, and then we'll create a data frame table for this result, and we'll store it in the result promoted section. So we'll use this pd.dataframe, and we'll give in the employee ID and is promoted, and it will have the predictions and the test set of the employee ID. Then this thing you need not to take care of. These are again the classifiers, and then you have to print list classifiers keys over here. So this will be same as previously we have used the classifiers over here. So this is the same thing. Now let me implement it and let us see the results. So list of classifiers, so XGBoost, CatBoost and Light GBM. Now next we'll print result promoted. So I'll type in print, then result, and now I'll run this, and you can see employee ID and is promoted. So these are all the IDs of the employees who are being promoted. So here you can see that the ID number 5973, so employee corresponding to this ID has been promoted. So this is how we implement it and get the result using the round of probability. Now next we have used the classifiers, that is classifier 1, classifier 2, classifier 3 for XGBoost, then Light GBM and CatBoost. So we are fetching the values and the index as same. We have used 0, 1, 2, and then we have used the array from the NumPy library and given the index over here, and then finally use the voting classifiers, and we have given the estimators as XGBoost, CatBoost and then LGBM for classifier 1, classifier 2 and classifier 3 represented by CLF 1, 2 and 3. Then voting again is soft. Then we will predict the class probabilities for all the classifiers using the predict underscore prob function and giving in the argument as X, and using the classifiers for the XGBoost, CatBoost and Light GBM along with the voting classifier that we have built over here. So all this we are using for predicting the probability. Now to get the class probabilities for the first sample in the dataset, we'll create two classes and then we'll create a 2D array and put a for loop where we'll use the probus instance that we have used for predicting the probability for the model using various classifiers. So these two has been created, and now we'll plot what we have created or what model we have created. So we'll plot. So we'll use n equal to 4, that is number of groups, then ind instance for np.arrange, so arranging these groups, and these are the group positions, and width will be 0135, that is bar width. Then we'll use figure and ax as the instance for the subplots. So we'll use the plotly package. So plt.subplots is the function that we have to use, and then bars for classifiers 1, 2, 3 and bars for voting classifiers. So for classifiers 1, 2, 3 we'll use the instance of p1 and p2 and use this ax.bar function where AX is the instance and bar is the function taking the parameter as IND, that is the group's position in np.hStack that takes the class probabilities that we have created, and the index -1 shows that it is taking all the values. Then the width is 0.35, then color, h color, and same for the second one, that is P2, where we'll use the second class that we have created. And for the bars, for voting classifier, we'll use the P3 P4 instance, we'll create it, and ax.bar, where bar is the function that we are using and ax is again the instance, and here the parameters are quite different, that is IND is same, but here we are giving 0 0 0. So instead of hstacks, that is np.hstack, we just given the values as 000 because it is a voting classifier and we cannot use hstag in it for this scenario. So the color is quite different, and now we'll set the plot annotations using the axv line. So it takes the argument as the value 2.8, color equal to k, line style equal to dashed, and then ax.set_x with ind plus width. So it is a matplotlib function that takes when the values are true and a minor tick when the values are false. Then set the x tick labels for xgboost, catboost, light GBM voting classifier, and the rotation will be 40. And now we'll give the y limit, that is 0 to 1, plot title, that is class probabilities for sample 1 by different classifiers, then plt.legend, that creates a legend for any plot, so for P1 and P2, and the values given over here is promoted no and is promoted yes, then location is upper right, then plt.tight layout, that helps to automatically adjust the subplot parameters according to the padding. Then finally we'll use this plt.show to show the plot. Now let me run this. So this is the final step of building our AI model and optimizing it using various feature engineering processes, classifiers and encoders. So this is the class probabilities for sample 1 by different classifiers. So here the dark green color shows the people who are not promoted and the light green color shows the people who are being promoted. And this is the voting classifier and its average probabilities. So this is the visualization of the probabilities for the employees who are being promoted and who are not promoted, but the actual values we already saw using these classifiers over here. So there are 23,490 records of 2 columns consisting of employee ID as it is unique. So it shows the corresponding ID and the promotion status of the employees. So I'll just go up. So here we have created the model and we saw that the model took 10.4 seconds, and this is the learning of the model we have created. The model using the voting classifiers and XGBoost, CatBoost, Light GBM, gradient boosting or extreme gradient boosting instead of that. And after that we have the results and we worked on improving it. Then we get the result of promoted, and finally we have visualized using the plot our results. So this visualization of the data is just for our understanding, but how actually is the code implemented using the algorithms in real time is by integrating it using other softwares. So company will not use this code directly. So what they will do is they will create the model using the code that we have built, and then what they'll do is they might have another application that shows the information of the employees and their various parameters such as age and other things that we saw. Let me go to that section where we have looked around the data. So employee ID, number of training, age, previous year rating. So they might have an application that show the data. So there they can add a feature that predicting the promotion, and whenever they click on that, so this code is added in the backend. So before it shows the prediction of the employees or before it shows the list of the employees, this code is being implemented and the results are shown on the interface. So this is how artificial intelligence or machine learning algorithms helps the company to resolve the issue for their various business problems. So here it is the status of the promotion, whether the employee has to be promoted or not. So it is not about this problem. There are many real life business problems that can be resolved using artificial intelligence and machine learning. So these algorithms and these methods are added in the pipeline of a static software or an application, and it gives the output and the result that is the best prediction according to the analysis using the algorithm along with using the data set that is being provided by the organization, and it makes that software or the application as AI based application. So this is how we implement various scenarios using artificial intelligence.
Just a quick info, guys. Test your knowledge of NLP by answering this question. Which of the following includes major tasks of NLP? A. Automatic summarization. B. Discourse analysis. C. Machine translation. D. All the mentioned above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session. Just a quick info, guys. Intellipaat provides NLP training using Python mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
Now let us begin with NLP interview questions and answers. So the first question is, what do you understand by natural language processing? So natural language processing is a field of computer science that deals with communication between computer systems and humans. So NLP is revolutionizing the user experience of various technologies. NLP is implemented in various areas to provide voice automation, text analysis, better customer service, and many more. Also, it is a technique used in artificial intelligence and machine learning, and it is used to create automated software that helps understand human spoken languages to extract useful information from the data it gets in the form of audio. And techniques in NLP allow computer systems to process and interpret data in the form of natural languages. Now, let us move on to the next question, which is, what are stop words? So stop words are said to be useless data for a search engine, and words such as articles, prepositions, etc. are considered as stop words. So there are stop words such as was, where, is, am, and how, why, and many more. So natural language processing, we eliminate the stop words to understand and analyze the meaning of a sentence. So the removal of stop words is one of the most important tasks for search engines, and engineers design the algorithms of search engines in such a way that they ignore the use of stop words. This helps show the relevant search result for a query. Further, let us move on to the next question, which is, list any two real life applications of natural language processing. So the first one is Google Translate and the second one is chatbot. So talking about Google Translate, it is one of the most famous application of natural language processing. It actually helps convert written or spoken sentences into any language. Also, we can find the correct pronunciation and meaning of a word by using Google Translate. So it uses advanced techniques of natural language processing to achieve success in translating sentences into various language. So you can see over here in the image how French sentence is converted into English using Google Translate. So basically, what is the use of Google Translate? So Google Translate can actually translate multiple forms of text as well as media, which includes text, speech and text within still or moving images also. Specifically, its function includes written words translation, and where a function that translates written words or text to a foreign language. So it can be called as a free multi-language neural machine translation that is developed by Google to translate text as well as the entire websites from one language into another. And also its accuracy, which has been criticized over time and over several occasions, has been measured to vary greatly across languages. So the application of this neural network, or you can say the natural language processing, which is Google Translate, so it can translate up to 103 languages in a number of ways, and you can just type words and sentences, speak them to the device by tapping the microphone, or even use your finger to handwrite. Now the next application is chatbot. So to provide a better customer service, companies have started using chatbots for 24/7 service, and chatbots helps resolve the basic queries of a customer. And if a chatbot is not able to resolve any query, then it forward it to the support team while still engaging the customer. So it helps make customer feel that the customer support team is quickly attending them. With the help of chatbots, companies have become capable of building cordial relations with customers, and it is only possible with the help of natural language processing. Now let us move on to the next question, which is, what is TF-IDF? So the term TF-IDF, or term frequency inverse document frequency, indicates the importance of a word in a set, and it actually helps in information retrieval with numerical statistics. For a specific document, TF-IDF shows a frequency that helps to identify the keywords in a document. Also, the major use of TF-IDF in NLP is the extraction of useful information from the crucial documents by statistical data, and it is ideally used to classify and summarize the text in the documents and filter out stop words. So TF actually helps to calculate the ratio of the frequency of a term in a document and the total number of terms, whereas IDF denotes the importance of the term in a document. So here is the formula for calculating TF-IDF. So first we have to calculate TF for a word. So it is equal to frequency of word, that is W, in a document divided by the total number of terms in the document. And for calculating IDF, the formula is log E times the total number of documents divided by the number of documents having the term W. So when TF-IDF is high, the frequency of the term is less, and vice versa. So Google uses TF-IDF to decide the index of search results according to the relevancy of pages, and the design of the TF-IDF algorithm helps optimize the search results in Google, and it helps quality content rank up in the search results. So this was about TF-IDF. Now let us move on to the next question, which is, what is syntactic analysis? Now syntactic analysis is a technique of analyzing sentences to extract meaning from it. So using syntactic analysis, a machine can analyze and understand the order of words arranged in a sentence, and NLP employs grammar rules of a language that helps in the syntactic analysis of the combination and order of words in the document. So there are various techniques used for syntactic analysis, and that are as follows. So the first one is parsing. So it helps in deciding the structure of a sentence or text in the document, and it helps analyze the words in the text based on the grammar of the language. Now coming to word segmentation, that is the next technique. So the segmentation of words segregates the text into small significant units. Then the next technique is morphological segmentation. So the purpose of morphological segmentation is to break words into their base form. Then stemming, so it is the process of removing the suffix from a word to obtain its root word. Then comes lemmatization, that helps combine the words using suffixes without altering the meaning of the word. So this was about the syntactic analysis. Now let us move on to the next question. What is semantic analysis? So semantic analysis helps make a machine understand the meaning of a text, and it uses various algorithms for the interpretation of words in sentences. It also helps understand the structure of a sentence. So there are certain techniques used for semantic analysis, and these are shown in the diagram. So first one is named entity recognition. Second one is word sense disambiguation. After that, natural language generation. So starting with the first one, the named entity recognition. This is the process of information retrieval that helps identify entities such as name of a person, organization, place, time, emotion, and etc. Then coming to word sense disambiguation, it helps identify the sense of a word used in different sentences. Then in natural language generation, it is a process used by the software to convert the structured data into human spoken languages. By using NLG, organizations can automate content for custom reports. So this is about the semantic analysis. Now let us move on to the next question, which is what is NLTK? So NLTK is a Python library which stands for Natural Language Toolkit, and we use NLTK to process data in human spoken languages, and NLTK allows us to apply techniques such as parsing, tokenization, lemmatization, stemming, and more to understand natural languages. So it helps in categorizing text, parsing linguistic structure, and analyzing documents, and many more. So here are few of the libraries of NLTK package that we often use in NLP, and these are sequential back-off tagger, default tagger, unigram tagger, tree bank, wordnet, frick, dist, patterns, regex speed tagger, back-off tagger, unigram tagger, bigram tagger, and trigram tagger. Now this is about the NLTK package. Now let us move on to the next question, which is how to tokenize a sentence using the NLTK package. So tokenization is a process used in NLP to split a sentence into tokens. So sentence tokenization refers to splitting a text or paragraph into sentences. So for tokenizing, we can import sent_tokenize from the NLTK package using the line of code that you can see on your screen, that is from nltk.tokenize import sent_tokenize, and after that we can give the argument as a paragraph, that is, hi guys, welcome to Intellipaat. This is a tutorial on the NLP interview questions and answers. So after tokenizing, we'll get the output as the splitted sentences, that is, hi guys, welcome to Intellipaat, and finally this is a tutorial on NLP interview questions and answers. So here you can see the paragraph is splitted into different sentences. So this is how we tokenize a sentence using the NLTK package. Now let us move on to the next question, which is explain how we can do parsing. So parsing is the method to identify and understand the syntactic structure of a text. So it is done by analyzing the individual elements of the text, and the machine passes the text one word at a time, and then two at a time, further three, and so on. So when the machine passes the text one word at a time, then it is called a unigram, and when the text is parsed into two words at a time, it is a bigram, and further the set of words is a trigram when the machine passes three words at a time. So you can see the diagram over here. It represents the unigram, bigram, and trigram. So the sentence is top 30 NLP interview questions and answers. So while parsing the text one word at a time, it gives us the output as top 30 NLP interview questions and answers separately. Each word is separate. So this is unigram. And while coming to bigram, it gives or it parses two words at a time, that is top 30 NLP interview questions and answers. So these are two word at a time and they are called bigrams. Then finally trigram, so it parses three words at a time. So it takes top 30 NLP interview questions and answers. So it is parsed three word at a time. So they are called trigram. So to tokenize a text, we can use word tokenized from the NLTK package, and for extracting unigrams, bigrams, and trigrams, we use the functions named unigrams, bigrams, and trigrams by using the NLTK package. So we use it like nltk.unigrams and we give the argument as the text, then nltk.bigrams, then we give the text, and nltk.trigrams and give the text, and then we'll get the output. Also, for getting the text or the parsing for n-grams, we use nltk.ngrams and we give the text with the argument n, which help us to tell the machine that we have to parse the text in for this many number of tokens. So this is about how can we do parsing. Now let us move on to the next question, which is explain stemming with the help of an example. So in natural language processing, stemming is a method to extract the root word by removing suffixes and prefixes from a word. For example, we can reduce stemming word to stem by removing m and ing. So we use various algorithms for implementing stemming, and one of them is Porter stemmer. So this is a basic code you can see on your screen to implement stemming. So from NLTK.stem, we have to import Porter stemmer. Then we have to create an object for Porter stemmer using the PST equal to Porter stemmer. Then after that, for stemming the word, we use PST, that is the object for Porter stemmer dot stem, and then we give the argument in the form of a word that we need to stem out. Then here we have given PST dot stem for running, PST dot stem for cookies, and PST dot stem for flying, and then we get the output as run, cookie and fly. So this is how we do stemming. Now let us move on to the next question, which is explain lemmatization with the help of an example. So we use stemming and lemmatization both to extract the root words. However, stemming may not give the actual word, whereas lemmatization generates a meaningful word by extracting the root, or you can say the actual root word, from the word that you have given. So in lemmatization, rather than just removing the suffix and the prefix, the process tries to find out the root word with its proper meaning. So for example, if we have a word called bricks, so it becomes brick. Corpora becomes corpus. So we can implement lemmatization using the below code. So first we have to import certain packages from NLTK. So here is the code. From NLTK.stem, we have to import WordNet. Then from NLTK.stem, we have to import WordNet Lemmatizer. Then we have to create an object for WordNet Lemmatizer. So for this, we'll use this lemma for lemmatization, and we'll use this method WordNet Lemmatizer. So we'll give the list as dogs, corpora and studies. So we'll implement the logic for n in the list, where n is the number of elements. Then we have to print n plus the word that we have lemmatized. So after the implementation, or you can say the proper implementation of lemmatization, will get the result as dogs become dog, corpora become corpus, and studies become study. So this gives us the actual root word from the words that we have input in the algorithm, or we can say the logic. So lemmatization actually generates a meaningful word. Now let us move on to the next question, which is what is parts of speech tagging. So the parts of speech tagging is used to assign tags to words such as nouns, adjectives, verbs and many more. So the software uses the POS tagging to first read the text and then differentiate the words by tagging. So the software uses algorithm for the parts of speech tagging. So POS tagging is actually one of the most essential tools in natural language processing, and it helps in making the machine understand the meaning of a sentence. So POS tagging is also essential for building lemmatizers, which are used to reduce a word to its root form. Also, POS tagging is the process, you can say, of marking up a word in a corpus to corresponding part of a speech tag based on its context and definition. So this is about parts of speech tagging. Now let us move on to the next question, which is explain named entity recognition and its benefits. So named entity recognition is an information retrieval process, and NER helps classify named entities such as monetary figures, location, things, people, time and many more. So it allows the software to analyze and understand the meaning of the text, and it is mostly used in NLP, artificial intelligence and machine learning. So one of the real life application of NER is chatbots used for customer support. Also, one additional information to add, the package for implementing the named entity recognition is available in Spacy package. So we have to import Spacy for implementing the named entity recognition. Now let us move on to the next question, how to check word similarity using the Spacy package. So to find out the similarity among words, we use word similarity, and we evaluate the similarity with the help of a number that lies between 0 and 1. So we use the Spacy library to implement the technique of word similarity. So here is the code. First we have to implement Spacy, then we'll use this NLP keyword where we'll load the requirements for implementing the word similarity using spacy.load, and then we have to input the word, then we have to implement the logic for I in tokens, and first we'll take I dot text, then I dot has vector, then vector underscore norm, and so on with token 1, token 2. So then we have to print similarity between words, where we'll use this similarity function. So if we want to check the similarity between token 1 and token 2, so we'll use it as token underscore 1 dot token underscore 2 inside similarity function, and then we'll get the output. So when we'll get the similarity, or we can say the parameter or the value is between 0 and 1, so you can see it over here, 0.597265. So this shows us the extent of similarity between the words. So this is about how can you check the word similarity using the Spacy package. Now let us move on to the next question. List the components of natural language processing. So here are the major components of natural language processing, that is entity extraction, syntactic analysis, pragmatic analysis, morphological and lexical analysis. So starting with the first one, so entity extraction refers to the retrieval of information such as place, person, organization, etc. by the segmentation of a sentence. So it helps in the recognition of an entity in a text. Now coming to syntactic analysis, so syntactic analysis help draw the specific meaning of a text, and then pragmatic analysis is used to find useful information from a text. We implement pragmatic analysis technique. Then coming to morphological and lexical analysis, it helps in explaining the structure of a word by analyzing them through parsing. So these are the components of natural language processing. Now let us move on to the next question. So define the terminology in NLP. So there are various terminologies in NLP that actually helps to implement NLP for any application, and the interpretation of natural language processing depends on various factors, and there are certain terminologies to define them, and they are as follows. So there are weights and vectors, structure of the text, sentiment analysis, classification of text, machine reading. So starting with weights and vector, we use TF-IDF. So we already discussed what TF-IDF is. So just for a recap, TF-IDF, or you can say the term frequency inverse document frequency, indicates the importance of a word in a set, and it actually helps in information retrieval with numerical statistics. So talking about a specific document, TF-IDF shows a frequency that helps identify the keywords in a document. And also the major use of TF-IDF in NLP is the extraction of useful information from crucial documents by using the statistical data, and it is ideally used to classify and summarize the text in documents and filter out stop words. Also we saw the formula for calculating TF-IDF, then we look into the length, and we also look into the Google word vectors and the individual word vectors. Then comes structure of the text, where we use POS tagging, head of sentence, and named entity recognition. So just for a recap, named entity recognition is an information retrieval process, as we already discussed about it, and it helps classify named entities such as monetary figures, location, things, people, time, and many more. Also it allows the software to analyze and understand the meaning of the text, and it is mostly used in NLP, artificial intelligence, and machine learning. And one of the real life example that we already discussed is chatbots used for customer support. Then comes sentiment analysis. So the knowledge of characteristics of the sentiment that we use for building the application, also knowledge about entities and the common dictionary available for sentiment analysis. Then comes classification of text, where we use supervised learning algorithm, training set, validation set, test sets, features of the text, as well as LDA. Then comes machine learning, where we use removal of possible entities, joining with other entities, and DBpedia for creating the application such that the outcome, or you can say the prediction of the machine, is accurate. Now further, let us move on to the next question, which is what is latent semantic indexing, that is LSI. So the latent semantic indexing is a mathematical technique used to improve the accuracy of the information retrieval process, and the design of LSI algorithm allows machines to detect the hidden, that is called the latent, correlation between semantics, that stands for words in NLP. So to enhance the information understanding, machines generate various concepts that associate with the word of a sentence. Then the technique is used for information understanding, and it is called singular value decomposition, and it is generally used to handle static and unstructured data. Also, the matrix obtained for singular value decomposition contains rows of words and the columns for documents. So this method best suits to identify the components and group them according to their types. So the main principle behind using LSI in natural language processing is that words carry a similar meaning when used in a similar context. So the objective of using LSI is used to find the similar context. So the computational LSI models are slow while using in natural language processing in comparison to other models for identifying the similar context meaning sentences. However, they are good at contextual awareness that helps improve the analysis and understanding of a text or a document. So this is about LSI. Now let us move on to the next question, which is what are regular expressions? So a regular expression is used to match and tag words, and it consists of a series of characters for matching strings. Suppose if A and B are regular expressions, then the following conditions will be true for A and B. So if epsilon is a regular language, then epsilon is a regular expression for it. And if A and B are regular expressions, then A plus B is also a regular expression within the language A, B. Then comes if A and B are regular expression, then the concatenation of A and B, that is A dot B, is a regular expression. And the final one is if A is a regular expression, then A times A, that is occurrence of A multiple times, is also a regular expression. So these are the rules of regular expressions. Now let us move on to the next question, which is what is a regular grammar? So a regular grammar is used to represent a regular language, and a regular grammar comprises rules in the form of A stands for small a stands for small a dot b, and many more. So the rules help detect and analyze strings by automated computation. So regular grammar consists of 4 tuples. So there is n that is used to represent the non-terminal set. Summation represents the set of terminals, then P stands for the set of productions, and then the S epsilon n denotes the start of a non-terminal. So this is about regular grammar. Now let us move on to the next question. Explain dependency parsing in NLP. So dependency parsing helps assign a syntactic structure to a sentence. Therefore, it is also called syntactic parsing. Also, dependency parsing is one of the critical tasks in NLP, and it allows the analysis of a sentence using parsing algorithms. So there are various types of parsing algorithms available in NLP that we use to parse a sentence. Also, by using the parse tree in dependency parsing, we can check the grammar and analyze the semantic structure of a sentence. So for implementing dependency parsing, we use the Spacy package in Python that we have, and it implements token properties to operate the dependency parse tree. So here is a diagram that shows the dependency parse tree. So the sentence over here is Jonas and Riley sells pen. So the root word is sell, and then Jonas and Anne are connected with a conjunction. Then coming to subject, so and sell are connected, and it is given the subject category. Then comes Riley, so it is again a conjunction. Then object is defined by sell pens. So this is actually a dependency parsing tree that help us to understand the meaning of a sentence and make the machine understand the meaning of a sentence. So this is about dependency parsing in NLP. Now let us move on to the next question. What is the difference between NLP and NLU? So the below table shows the difference. So NLP stands for, as you already know, natural language processing, and NLU stands for natural language understanding. So starting with the first difference, NLP is used to create systems capable of establishing communication between humans and computers, whereas in NLU, it provides techniques to solve complicated problems related to machine learning understanding. Then the next difference is NLP takes care of all the techniques required for the interaction between machines and humans, whereas in NLU, it actually helps convert the unorganized input data into a structure format to allow the machine to understand the data. Then the third difference is NLP provides techniques to analyze what is actually said, and in NLU it actually helps understand what actually the sentence is or what is meant by this sentence. Now let us move on to the next question, which is what is the difference between NLP and CI? So again, NLP is natural language processing and CI stands for conversational interfaces. So starting with the first difference, so NLP helps analyze and identify user requests. whereas a conversational interface helps mix images, videos, audios with menus, buttons, and many more. Then coming to the next point, NLP helps understand and interpret everything about a text or a document, whereas CI provides only the necessary information to users. Now the third difference is NLP is used by chatbots for providing customer supports, whereas CI helps provide better customer service by understanding user queries as well as responding to them and providing a personalized experience. So this is the major difference between NLP and conversational interfaces. Now let us move on to the next question, which is what is pragmatic analysis? Now, pragmatic analysis is an important task in NLP for interpreting knowledge that is lying outside a given document. And the aim of implementing pragmatic analysis is to focus on exploring a different aspect of the document or the text in a language. Now, this requires a comprehensive knowledge of the real world. So, the pragmatic analysis allows software applications for the critical interpretation of the real world data to know the actual meaning of the sentences and words. So, just for an example, consider this sentence, do you know what time it is? So this is a question that the machine needs to understand. So this sentence can either be asked for knowing the time or for yelling at someone to make them note the time. So this depends on the context in which we use this sentence. So that is why we use pragmatic analysis for interpreting the knowledge that is lying outside a given document and not in the range of the machine. So we need to train the machine in such a way that it can interpret this type of knowledge. Now let us move on to the next question, which is what is pragmatic ambiguity? So pragmatic ambiguity refers to the multiple descriptions of a word or a sentence, and an ambiguity arises when the meaning of the sentence is actually not clear and the words of the sentence may have different meanings. Therefore, in practical situations, it actually becomes a challenging task for a machine to understand the meaning of a sentence. So this actually leads to pragmatic ambiguity. Now, just for an example, here is the sentence given over here. So, are you feeling hungry? So the given sentence could be either a question or a formal way of offering food. So for this, we need to train the algorithm, train the machine in such a way that it can differentiate and it can interpret both the meaning and the context of the sentence. So this is pragmatic ambiguity. Now coming to the next question, what are unigrams, bigrams, trigrams and n-grams in NLP? So to understand them, let us look at an example. So here is a sentence, I am feeling hungry. So as per the given sentence, it is given over here unigram, bigram and trigram. So just for a recap, when we pass a sentence one word at a time, then it is called a unigram, and when the sentence is passed 3 words at a time, it is called a trigram. Similarly, n-grams refer to the passing of n words at a time. Now coming to the example, so in unigram, each part of the sentence you can see it over here, that is I am feeling hungry. So these are unigrams. And coming to bigrams, so I am is a single entity, then am feeling is another one consisting of 2 entities, or you can say 2 tokens. Then comes feeling hungry, so again a single entity. So this is bigram. Then coming to trigram, it has 3 entities together. I am feeling hungry. So similarly, if we take n grams, that is after parsing 3 words at a time, if it is necessary to parse 4 words at a time, 5 words at a time, then it will be according to the similar pattern that we use in unigram, bigram and trigram. Now let us move on to the next question. What are the steps involved in solving an NLP problem? So these are the steps that actually we use for solving a real life NLP problem. So first we have to gather the text from the available dataset or by web scraping. So data collection is one of the important tasks before solving any problem in the field of AI, machine learning, data science, as well as in NLP in context of as we are dealing with text. So then we have to apply stemming and lemmatization for text cleaning. Then we have to apply feature engineering techniques and then embed using word2vec. After that, we have to train the build model using neural networks or other machine learning techniques. So on top of the data set or the text that we are using, we have to use any machine learning algorithm or any neural network so that we can train the model on a particular data set, so that in future it give us the results if we input new data. Then we have to evaluate the model's performance on the basis of certain parameters that are available. Then we have to make appropriate changes in the model. So if the model's performance is low, then we have to make changes so that the model is more accurate. So we use various techniques for that. And finally, we have to deploy the model for using it in real life. So these are the steps that actually we use for solving an NLP problem. Now let us move on to the next question, which is what is parsing in context of NLP? So parsing in NLP refers to the understanding of a sentence and its grammatical structure by a machine, and parsing allows the machine to understand the meaning of a word in a sentence. Also the grouping of words, there are phrases, nouns, subjects and objects in a sentence. So parsing actually helps analyze the text or the document to extract useful insights from it. So to understand parsing, let us look at an example. So here sentence is given over here, that is Jonas ate an orange, and starting from the top, so there is category named sentence, and it has two categories, noun phrase and verb phrase. Again, noun phrase has another subcategory named as proper noun, and Jonas is assigned to the category of proper noun. Then coming to the second category, that is verb phrase. Again, it is having two subcategories of verb and noun phrase. So 8 is assigned to the verb category. Now the words that are left are an and orange. So there is determiner and noun. So orange is a noun and determiner is an. So Jonas ate an orange. So this is actually the parsing in context of NLP. So this is how we actually implement NLP solutions. We actually solve NLP problems using parsing. Now let us move on to the next question. What is feature extraction in NLP? So features or characteristics of a word help in context or document analysis. Also they help in sentiment analysis of a text. So feature extraction is one of the techniques that are used by recommendation systems and for giving reviews such as excellent, good or great for a movie, or it can be negative. So all these are recognized by a recommender system. So the recommender system actually tries to identify the features of the text that help in describing the context of a word or a sentence, and after that it makes a group or category of the words that have some common characteristics. Now whenever a new word arrives, the system categorizes it as per the labels of such groups. So this is how we use feature extraction, and it is used in recommendation engine used by most of the companies such as Amazon, Flipkart, Myntra and many more. Now let us move on to the next question, which is what is precision and recall? So the metrics used to test an NLP model are precision, recall and F1 score. Also we use accuracy for evaluating the model's performance. So the ratio of prediction and the desired output gives the accuracy of the model. So precision is actually the ratio of true positive instances and the total number of positively predicted instances. So precision's formula is actually true positive divided by the sum of true positive plus the false positive. So we can also write it as true positive divided by total predictive positive. Then coming to recall, it is the ratio of true positive instances and the total actual positive instances. And the formula for calculating recall value is true positive divided by the sum of true positive and the false negative. So we can also write it as true positive divided by total actual positive. So this is about precision and recall. Now moving on to the last NLP interview question, what is F1 score in NLP? So F1 score evaluates the weighted average of recall and precision, and it considers both false negative as well as the false positive instances while evaluating the model. So F1 score is also more accountable than accuracy for an NLP model when there is an uneven distribution of class. And further, formula for calculating F1 score is 2 times the multiplication of precision and recall divided by the sum of precision and recall. So F1 score is actually one of the important parameters that we use that actually gives us a measure of model's accuracy on a particular data set, and the F score is a way of combining the precision and recall of the model, and it is also defined as the harmonic mean of model's precision and recall.
Just a quick info, guys. Intellipaat provides NLP training using Python mentored by industry experts, the course link of which is given in the description below. So guys, we have come to the end of the session. Hope you all enjoyed it. If you have any doubts, please put down in the comment section below. We will try to answer it as soon as possible. Thanks for watching.